Okay, hello everyone. This is week 7, day 2. We have the objective for today. We're going to look at subqueries in order to complete yesterday's objective. And for today, we're going to look at stored procedures. It depends how far we can go with stored procedures. Then I'm going to introduce variables. Right. So let's talk about subqueries. We talk about variables. And time permit, we're going to talk about stored procedures, then variables. The concept of variables is within stored procedures. I'm going to probably have to introduce that before we get to stored procedures. Okay, so like I was saying, there was a set of MCQs from yesterday, day 1. So you had these questions attached from yesterday. Let's see. Let's begin with the simple ones. Let's look at this question right here. So in SQL, you are able to sort only one column, or can we sort the data on multiple columns? If you look at the order by, this is a question on the order by. Can the order by carry just one column, or can we place multiple columns on the order by? Is it restricted to one column, or can we sort on multiple columns on the order by? Which one is correct? So this is testing your knowledge of the order by. That's where the sorting takes place.
I would say the second. It can be sorted on multiple columns as long as we use a separator between each.
Yes. So yeah, the second column you add on the order by, that's a tiebreaker. So yes, you can sort by multiple columns, right? So these things, you can try them out practically. Let me just see if I can connect to one of these databases and we just try this out practically. Hopefully my system is not going to be slow today. Let's see. Let's go to Adventure Works. I will target, for example, maybe the products table is going to be on production products. Production products. I should be getting IntelliSense Hub. Just a moment. Let me switch to the light one. Okay, this is slow. Anyway, I'm going to come back to that. Let's go to the, target the next one while waiting for this query to execute. Okay, this is a question on joins. So if you want to join two tables and only have matching entries from both tables and exclude any non-matching entries, which type of join needs to be used? Just a moment before let me address this so that we can move forward. I want to sort on list price. So I bring in the list price. So let's order these products by list price. So this is the first column on the order by list. And of course, this is going to be ascending if I don't put this or this. So you have to understand that ascending is a default. If I dismiss this, the system is going to do sort on list price ascending. Okay, this is really frustrating. Anyway, so let's take a look at this one on joins. So if you want to join two tables and only have matching entries from both tables and exclude any non-matching entries, which type of join needs to be used? Left, full outer, right, inner join. Which one is correct? So try to read the question, draw two Venn diagrams, make them intersect, and then try to identify the shaded region. That's an easy way to answer this question. Remember, we use Venn diagrams to represent joins, and that's the best way to understand the concept of joins. Strongly advised to use Venn diagrams. So if you want to join two tables and only have matching entries from both tables and exclude any non-matching entries, which type of join needs to be used? So I'll always strongly recommend the idea of drawing so these are two tables. We have table 1 and table 2. So we read the requirement and identify the region of interest. If you want to join two tables and only have matching entries, this is a very key part of this question, only have matching entries from both tables and exclude, see, very important, exclude any non-matching entries. Which type of join needs to be done?
An inner join.
Definitely is going to be an inner join. I'm hoping that everyone is able to identify this. This is going to be an inner join. This is the region of interest. Only have matching entries from both tables. This is where the matching entries from both tables, this is a region, right? And it further tells you to exclude any non-matching entries, right? These ones are the non-matching entries on table 2. These ones right here are the non-matching entries from table 2. So the only zone that correctly identifies this is this zone right here, and this is typical of an inner join. This is very, very important. In a full join, you're targeting all the regions. So the entire T1 and T2 will be shaded. That's when you know you're dealing with a full join. In a left join, this is going to be a left join scenario. You're targeting all the rows, all data from the left table. If table 1 is our left table and table 2 is our right table, then an inner join will give you the matching entries. Sorry, a left join will give you the matching entries. And the question will tell you to also include any non-matching entries from the left table. That is how you're going to add this part. So we target the inner join, the inner intersection, and then also include any non-matching entries from the left table. This is me adding the non-matching entries from the left table. So all these join types always have the inner join. They always have this intersection. All join types have this intersection. Now, depending on how the language of the question is structured, you can identify the next zone. So this extension tells you exclude any non-matching entries. So this is what you're left with. If we had include right here, they will specifically tell you the site on which the inclusion will be done. Right, let me draw another scenario. If I have this other scenario, I get the intersection. Always remember the intersection is present on all join types. Now this is my T1 and this is my T2, and I'm told to include all non-matching entries from the right side, from the right table. Now this is what you do. This is the left table, so I'm going to the right table and I'm including all the non-matching entries from the right side. See, this thing is really easy if you use Venn diagrams. I would strongly advocate the use of Venn diagrams to illustrate joins. This is very important. Read the question and try to capture it visually. And of course, if you want the picture for the full join, you can never miss out on a full join. This is T1, this is T2. We are getting everything across both. The entire region across both tables will be shaded. This is a full join. The extremes are full join and inner join. This picture should never leave your mind. The picture of a full join and that of an inner join. And now this is what a left join. The moment you see that the left table, the non-matching records on the left table are also part of the picture. You have two zones, the intersection and the left side. This is a left join. You cannot confuse this. There are some questions that when you go to an interview, they ask you and you mess up, they cannot forgive you. Some companies even write down if the candidate cannot answer this question, disqualified automatically. Right. See, so you have to be very careful, guys. So this is the left join. This is going to be a right join. This is an opportunity for us to review this concept again. See, we have the non-matching records are coming in from the right side of this. T2 is a right table. So once those non-matching records are coming into the final result, you're dealing with the right join. So you have the intersection zone 1 and then zone 2, the non-matching records from the right hand side. You have the intersection zone 1, the non-matching records from the left side. This is a typical left join, right join, full join, inner join. You cannot mix this up. See? Right. Any question on this? I hope this is a nice revision on joints. Any question on this? Okay, I'm going to dismiss this. Let's try the next one. Let's just erase everything. Okay, let's go to the next question. So this was the second one. Let's look at question 4. During which clause are window functions evaluated? We studied window functions last week. So during which clause are window functions evaluated? Where did we build those window functions? Is it select, from, where, order by, group by, having? Where did we place the window functions? We build them within the select statement, yes, but which keyword? These are all the keywords in the select statement. Where did we create those window functions? Just go back to your notes, open any of the queries we did a window function, check where the window function is placed within the select statement. I really want you guys to discover this on your own. So check this thing is still running. This is yeah, I'm gonna need somebody to answer this. you can check, you can go to the examples we did on window function, check where those window functions were specified. Is it at the order by, the where, the select, group by, or the from?
Wasn't it in the select clause?
Definitely on the select. Yeah. This is very important, you see. So window functions are evaluated at the select clause. In the examples we've used window function, they came in as a column. We use them to build a column, and columns are built at the select clause. Moving forward, you're going to notice when we get to the week 8, you cannot use window functions on the where clause. Window functions can only be used in the select, and of course, they're going to generate a column. The alias now can be referred to in the order by. So you cannot use a window function on the where clause. You cannot use it in the group by. You cannot use it in the from. You can only use it on the select. And if it builds a column alias, you can now use that column alias in the order by. Right. So I'm going to come back to this concept again in week 8. But you have to know this from the examples we've solved. All the window functions we use them within the select clause. So all of this defines what they call the select statement. But when you identify one of these, this is a clause or a keyword. You cannot say the order by statement. There's nothing like the order by statement. The order by statement belongs to the select statement. So a statement is like a sentence, and then words are put together to define the sentence. So in SQL, we have keywords. Right? Keywords are put together to define a statement. So we have the select statement. These are the components of the select statement. So don't go to an interview and talk about the select, the where statement, order by statement. If you isolate this alone and you want to talk about this is the select keyword or the select clause. It is a component of the select statement. Yeah, you see in interviews, people confuse these words. Right. Okay, let's go to the next. This one, question 3. Okay, will these two select statements evaluate the same? What is the main difference between these two? If you look at carefully, it's just they are trying to highlight these two concepts, left and right. This is the difference between these two. This one has left join, and let me highlight the next one. This one highlights a right join. So putting everything together, will these two select statements evaluate the same? I've always said that a left and a right join can be used to solve the same question, but then you have to look at the placement of the tables. They should respect the positions of the tables if they are going to end up resulting to the same or evaluating the same. So this is a left join from the keyword left. Our table of focus is what? This is the main table in this analysis. So TBL first is on the left side. So this is a priority table. We are getting all records from this table together with the matching ones from this table. All right. So once you understand this structure, take that same knowledge to this one. Right join. As long as TBL first is now switched to the right hand side. See, TBL first is on the left hand side for this statement. TBL first is on the right hand side for this statement. So these two select statements are prioritizing the same table. Left join is prioritizing TBL first. Right join is prioritizing TBL first. So yes, these two statements will evaluate the same. Any question you can solve with a left join, you can solve that same question with a right join, but you must prioritize the tables. You must place them in the right order based on the join type you're doing. So if you're doing a left join, just check and make sure that the table on the left hand side, this table is prioritized same as this side. See, so these two will be the same. I hope I don't know if this is understood. I want to stop right here for questions. Is this understood? So one thing to check if you are given this kind of question, check if a left join and a right join will evaluate the same. Just go and check the prioritized table. If the two statements have the same prioritized table, then they will evaluate the same. So that's just the test you have to do. All right, so this question is simple. Does a left join and a right join evaluate the same? They can only evaluate the same provided they are prioritizing the same table. So if I go to the left hand side, the prioritized table on the left join should be on the left side, this one. And then if you go to the right join, the prioritized table on the right join should be on the right hand side, this one. So as long as they are prioritizing the same table, they will get the same result. So the answer here is true. Right. Will these two select statements evaluate the same? The answer is true. On the basis that they are prioritizing the same table. TBF first is on the left hand side, we're doing the left join. So what will it do? It will give you all records on the left side together with the matching records on the right side. Now, if you take that prioritized table and switch it and put it on the right hand side, yeah, you still get all the records from this side together with the matching from this side. So it boils down to the same thing. This is very important, right? Please stop me if you have any question or doubts that needs to be corrected. These are just revision questions just to trigger you and see how far we're going with this concept. Okay, let's take a look at this one. So what's the focus right here? The where clause, difference between the where clause and the having clause. By now you should be able to build this difference. Last time I took you guys to Google and I just typed where versus having and went to the image section. So where versus having, these are popular interview questions. Where versus having, make sure you put the language SQL and you just go to images. Right, I think last time we checked, take a look at this. See right here. Now this one is just highlighting one of the difference. This one, the where clause can reduce the number of rows remaining only before the group by. So when you're looking at the where clause, the key things to focus is what? Rows, because the where clause filters rows. And the where clause comes in what? Before the group by. These are key things you have to, I'm happy we're doing this together. So in this kind of questions, always focus on key information. This is a key information. The where clause can reduce the number of rows. The where clause is applied at the row level filtration. And of course, the where clause comes in before the group by. If you look at the written order of the SQL keywords, sweaty feet will give horrible orders. In that order, let's go with the green, for example. So we have sweaty feet will give horrible orders. This is our where clause right here. This is our having clause right here. So clearly you see that the where clause is applied before the group by. This is a group by. This is our point of reference. See, before the group by takes place. So the where clause processes conditions at the row level before the group by takes place. This is true. See, the entire line right here is true. And then the second part, the having clause reduces the number of rows after grouping. after grouping has been done. This is very important. As long as you're seeing after the grouping, this is where the grouping takes place. And this is where the having clause is coming in. So the having clause reduces the number of rows after the grouping. This is true. So combining what we've seen in the where clause and what we've seen in the having clause, this statement evaluates to true. I want to stop right here for questions. Let me give you some time to check this out. Any doubts on this? So I'll strongly advise you all to check this. And also make it a habit, you see. Last time we checked this out, so always make it a habit to, just type keywords like this and compare them in a tabular format and just read through. This helps a lot to get the facts straight. The where clause is used to impose conditions on select statement as well as single row function, and it's used before. We saw this in that stuff before the group by. The haven't is used after the group by. This is very important. So when we combine that, this statement evaluates to true. This is true. Okay, let's go to the next question. This is the last one, question 1. This one has to do with, I think this is also something on the where clause. So if employee number is an integer, so that's the employee number is a column, right? And it's stored as an integer. Which of these will select employee numbers greater than 200, but not 200 itself? So we want greater than 200, but not 200 itself. So when you put it like this, it cannot be greater than or equal to. So you're definitely not looking at this scenario. Either this scenario has greater than 200, but also includes 200. So you should be looking at this, and there will be probably other variations of this. So before you even check out the outcomes, you just know what you are not looking at. So it should be strictly greater than 200. So in this condition, 200 is not involved. In this one, 200 is involved. So, but not 200 itself. So I'll give you time to go over this 1, 2, 3, 4, and then choose which one satisfies this condition. Employee numbers greater than 200. And this is a serious reminder, but not 200 itself. I really want you guys to think through this process and come up with the correct one. I will pause for a couple of minutes. 5 minutes. I'll pause for 5 minutes. These are 4 outcomes. 5 minutes should be enough. Okay, guys, we're back. So who wants to go first with this suggestion?
I will go with the second option.
The second one, I think from our explanation, we dismissed this already. We're all clear on this because this will include 200. We're trying to exclude 200, you see. So I'm going to exclude this. So Alex, you're going with the second one. So this one says where not, so there's a negation, employee number less than 200.
I think I read the question wrongly. My bad. That's it.
Okay, anyway, this is okay. So anyone had this in mind? Employee number. So if the positive is what, let's just ignore this not for now. Employee number less than 200. The opposite will mean greater than 200. Not. And these things are nice if you can actually try them out in any random database you have. Right. So employee number less than 200. This is strictly less than 200. So 200 is not part of this. But on the negation of this, I think 200 becomes part of it. Are we okay? So employee less than 200, 200, it's not part of this. But when you put a not less than 200, becomes part of this. Let me suspend this for now. Let's check out this one. Let's see what is wrong with it. So this one says that the employee number should be strictly greater than 199, or the employee number should be different from 200. Let's look at this side. You have to look at this separately. All right, let's look at this side first. Is 200 involved in this? Because our problem is to exclude 200. Is 200 involved in this? There is no 200 on this side. See, it clearly says employee number should be different from 200. It could be any other thing, but it should be different from 200. All right, and then let's evaluate this side separately. Why? Because that's an or. This one says that the employee number should be greater than 199. This will accommodate 200, yes or no? Yes, it will accommodate 200.
Yes.
Yes, so this, by that possibility of this accommodating 200, and this is an or, this is disqualified. Take note, if this is true, fine. If this is true, fine. That's the meaning of or. It doesn't mean this and this must be true. That's the meaning of and. So we've evaluated this side. It will not take 200 because it says strictly different from 200. But this side will accommodate 200. Now it fails on that condition. So this fails. Now let's look at the last one. This one is similar to this not stuff as well. So we just exclude the not for now. And let's look at the positive, and then we transform it now to negative to understand it better. So this one says employee number less than 200. Employee number less than 200. Now, if we bring in the not, employee number less than 200, 200 is not involved. Strictly less than 200. Now, if you bring in the not, it becomes greater than 200. Right, so this side of it becomes greater than 200, strictly greater than 200. Are we okay? So always look at the positive first, employee number less than 200, strictly less than 200. Now, employee number not strictly less than 200. In this case, 200 becomes involved. So we're now looking at from 200 and we're going this way. And usually if these things are not clear, you can always try to put them on the number line. If this is 200 right here, right? So this one says employee number less than 200. So we are looking at this zone right here. It's 200, less than 200, we're looking at this zone. And then not, you bring the not, now we are looking at this zone from 200 moving forward. This was the opposite that we negated. Starts by less than 200, it's going to be on this side. Not less than 200 is going to be from 200 and above, this direction. So that's what this one is accommodating. Now let's go to this side. And employee number different from 200. Remember that this side accommodates 200. That's why the arrow started. This is like the lower limit. This is where it begins. All right. Now this one comes in and dismisses the 200. So we can skip and go maybe to 201. If that's the next, let's just assume that's the next number, 201. So this condition makes sure that we are dismissing 200. So it's shifting the starting point to this, moving forward. So you should be greater than 200. That's what this evaluates. And then this second condition comes, which is also mandatory. You should not be equal to 200. So you should start maybe like 201 moving upwards. Does that reflect what we're looking at? Greater than 200, but not 200. So this one, potentially, it's the correct one. Let's see what is wrong with this one. Now we can go back to this. With this idea of number line, let's target this one and see. I suspended this one. Let's go back to it and use the number line. So on the number line, let's set 200. Then let's read the question and identify. First of all, let's look at the positive. So I'm looking at the parenthesis. Employee number less than 200. So less than means 200 is not involved. So I'm going to shift it right here. And this is our less than 200. See that? So 200 is not involved. Now, when you come in with a not, it means you're looking at the opposite side of this. Not now becomes a negation. The opposite of this direction will now involve this zone. See? So we have now switched, and this is the correct zone this will end up looking at. And in this zone, 200 is part of it. That's where this one failed. So on this, 200 is part of this zone. I had to learn this the hard way. I always like to visualize things. It helps. Probably when you're done with Power BI, moving forward, you start learning how to visualize things. Always try to visualize problems, visualize your solution. It helps a lot. As we've seen that in joins, visualize it through Venn diagrams, identify the correct spot. Right? Anything involving problem solving, always try to visualize it. Right? So let me repeat. This one seems a little bit tricky. I'm gonna repeat this. So we set the limit at 200. We look at the positive. It should be less than 200. So I'm not going to put it on exactly 200. I'm going to shift it right here. And then this is the zone of interest for the one in the parenthesis, not looking at the negation. So this is what we had. Employee number strictly less than 200. This is what we're looking at. So 200, not on 200 exactly, but less than 200. So not including 200. That's now when you bring in the not simply means the opposite of what you see right here. And I'm going to use the green color so that you see the difference. The opposite of what we are currently seeing is what the not is talking about. So you identify the positive and then negate it by looking the direct opposite. So this is less than 200. So it means that the opposite will begin from 200 and then on this direction. That's the opposite. That's where this fails because it begins at 200. The question clearly says 200 should not be part of it. See, now let me go back to this one and explain this again. So let's get the number line. We go back to red first since we have a negation to do. So the red will be used to indicate the positive, and then I'll bring in the negation. Take note that we have an AND operator right here. So these two must be mandatory. They must be fulfilled, unlike this one. Why did we fail right here? Because this is greater than 199. 200 is in this range. So that's why this failed. See, in this one, we begin by employee number less than 200. It starts off with this employee number less than 200. So if we set our 200 mark right there, less than 200, it doesn't involve 200. I'm going to shift the start right here. Less than, we're on this side. Less than 200, employee number less than 200. If you now look at the not less than 200, so you're going to the opposite direction. Let me use the green to indicate that. So this is now going to, the opposite will now begin at 200. It's going to begin at 200 and then extends this way. We've now added this not, and this is the scenario. That's just one side of it. Now go to the AND. It's a combination. Employee number different from 200. Remember that this first one included 200, so we're now shifting the limit from 200 to the next value. So different from 200. Different from 200 now starts. See, this now becomes the correct region we are targeting. And that region does not involve 200, which reflects the question. So this is the correct answer upon that verification. If this is the steps you have to go through to identify the correct one, then it's worth it. I will encourage you to always visualize things. Are we okay? Okay. Any question before we close this and begin the materials for today? Okay, sounds good. So I will shut this down. So I'm going to take you to yesterday's lecture so that we can conclude the subqueries info material. Only my system is going to allow me to run these queries. So go ahead and open the subqueries. Yesterday we talked about views. Today we're going to look at subqueries. So as I explained yesterday, sometimes it's difficult to solve a question using a single select statement. Right. So the idea of subqueries is very important because I bet you you're going to see questions where it will be difficult to use a single select statement to solve them. And I'm going to show you some key guidelines to identify such questions. There's always going to be a hidden part of the question. If I ask, give me the list of employees who earn less than Idris. So I'm looking at the salary. Anybody who earns less than Idris in the company, I want to see the list of such employees. A question is hidden in that question. You have to first of all know the salary of Idris. Before you want to investigate those who earn less than Idris in the company, you must know Idris' salary. So you discover that that's a separate search you have to do, which is important to the main search. That's typical questions to solve with a subquery. So you have to first of all investigate the salary of Idris. Then you can now write a select statement which will return all employees whose salary are less than that of Idris. This is very important, and that's how you target the subqueries. There are two or more select statements which are incorporated as one. Is basically a query inside another query. And we're going to see this in two parts. We're going to see the subquery one today, and then next week we're going to see the derived table one. That is going to be really interesting. These are some critical advanced techniques we are moving into, but it's simple. You know how to write a select statement, fine. Your focus now is just, hey, I really want to see how you can put a select statement inside another one. Yeah, you can write two separate select statements and then you join them together, put one inside the other, right? So the outer one is what they call the parent query. So it's basically a parent and a child query, right? So when one step just isn't enough, this is what I saw in one article. Yes, and it just simply means that sometimes a single select statement is not sufficient to solve a problem, right? You will need to use two or more select statements to solve that question. And of course, you have to combine them into one, put one inside the other. So all the queries we have written so far involve single select statement. When you use a single select statement to solve a question, right? In the real world, some business problems will need multiple select statements nested. This idea of nesting, we've talked about functions. When you put a function inside another function, that's nesting, right? So we're also going to see that in queries, you can put a query inside another one. I begin with this function by calling to this date, right? I get this outcome, and then I can proceed to the second phase by nesting. I don't want to get the entire date. I just want to get the year part. So this is how nesting is done. I now use the year function and nest within it. This is nesting from a function perspective. You have to begin reading this from the innermost part. So if you have this kind of thing in front of you, extract the inner one, run it like what we did right here. And then it's now similar to you. Instead of using that function, you just copy this and put it inside. But then this is static coding. See that? So you have to understand that this is the dynamic version of this. This is static. So it all begins by you understanding what is inside. That's how the query processes, the database engine processes. The inside is process, which gets this, and then we now use the year function on that outcome. So this is nesting, a function inside another function. See that? And we can take this and extend this. So take this. So it's going to print that year. Just to continue the nesting process, right? So this right here is just derived from this, and I'm using a concat function to take this 2024 and then a space is a great year. All right, but this is just nesting from a function perspective. Now let's look at nesting from a query perspective. That's the focus of subqueries. See, so in such a situation, we need to break the problem into small and more manageable pieces. So subqueries are best for straightforward two-step queries, right? So let's begin with some terminologies. A scalar subquery is when your subquery returns a single value. For example, I want to investigate the maximum list price. See, can we all switch this to 2022? Just put 2022 right here. So this is a format where I'm adding the database name, put the period, put the schema name, put the period, and put the table name. Alternatively, you can do the traditional approach we are used to, where we begin by disclosing the database name. So we do this, such that we don't need to put it in the from clause. Right. I just want to expose you to different scenarios. If you see your colleagues in the job doing this, some people like to attach the database name to the from clause. The advantage of this is, you see how I'm on master. If I execute, it's going to run because the name of the database is attached to the from clause. Even if this is pointing to a completely different database, it doesn't affect this query. This query is self-built. See, I've disclosed the database name, I've disclosed the table name, and I've disclosed the schema. Sorry, the schema and the table. So the system knows everything it needs to. Right, and see, it still works. Point this to any database, that query will still survive. I'm on Tesla, but I'm running this. As long as you've disclosed the database name, you're fine. It's going to survive. Right, but then check out this one. This is what we've been doing. You must execute the one above to connect to the database before you now run this. See, I am on Tesla. If I run this, I expect a failure because my from clause does not incorporate the database name. I get a failure. You see that? So this has an advantage in the sense that your query will always run irrespective of the database. So this one, you must run this first, switch it to AdventureWorks, then run this against AdventureWorks. See, right, that's just something I wanted to draw your attention to. So every time you see 2019, just switch it to 2022. That's the database we have. So I'm beginning some investigation right here. I want to look at the maximum list price. That's the value we get. Okay. Now, the average overall list price for all products. I switch to average function, same column. I'm getting now the average list price. So this gives me the maximum list price. This gives me the average list price. So I'm heading somewhere with this information. Now, all product information, this is a simple query to give me all product information. This is another query right here. I get the product ID, the name, standard cost, list price. Okay, now this is where the fun begins. Show product information for only products with list price greater than or equal to average overall list price. What is the average list price? That's something you have to investigate. See, this question has a hidden agenda. It has a hidden question. What is the average list price? So you can go and investigate the average list price. This is it. This is investigation right here, and just take this value and put it in the query. This query right here. Let's address the static part. So take this query. It's giving you all the information. Now I want to modify this to only show those products with list price above the average. This is the average list price. Copy this. That's the investigation we've done. See, if this question was asked and the value was given, then you just put the where clause and you point to that value. What's the question? It should be greater than or equal to the average. So where the list price is greater than or equal to average list price. This is list price greater than or equal to average list price. That's what we've coded. This is static coding. What if this value changes? Of course, database products are being added into the database, and of course, the average list price keeps changing. So what you've done right here, you've hard coded this value. This is going to work for the meantime. Databases keep changing. You have to understand that this is not a nice way to code. Right. So you have to take this query that investigates the average list price and put it in this position right here, not the outcome, so that at any given point, the system will run that investigation, average list price, get this value and fit it in this position. This is static coding. Right. So now we're heading somewhere with this. Let me switch this to 2022. Please just remember to switch that. We don't have 2019. So anytime you see that error, just switch 2022. So what I just did right here is what we call static coding. We've investigated the value of the average list price. Remember the question, all products, this has to go right below. Show product information for only products with list price greater than or equal to average list price. So there are two solutions right here. Some students will run this investigation to find the average list price, copy the value, and then use it in this query where the list price is greater than or equal to the average list price. Please just remember this is the value for the average list price. The question says only those products where the list price is greater than or equal to average list price. This is the list price column, greater than or equal to. This is the value we investigated. This value was not provided in the question. It just said average list price. You have to investigate that. So this is it. This is hard coding. The average list price value for today might be different tomorrow. And this does not take into account that possibility that the average list price could keep changing. So instead of hard coding this value like this, copy the query you use to generate this value and place it in this position. And that's what we're doing right here. You see, that's the query right there. We copy it, put it in this position. That query still runs and generates that value. And the steps for a subquery, you must put it in a set of parentheses. Let me make sure I highlight this. All right. So if I put it like this, it's not enough. If I run this, it fails. I'm violating a key point of subqueries. The inner query, which is this, which is called a subquery, must be placed in a set of parentheses. You have to remember this. This is very important. You see, the entire subquery has been enclosed in a set of parentheses, beginning, closing. See, and then this one can run independently. This will investigate the inner part. You see, like what we did right here. This one runs, generates a value before the outer one comes in. This is for functions. So for subqueries, it's the same. The innermost subquery is evaluated first. So it runs and generates this. Now, this value is exactly what we did previously. We'll dismiss this and put this. Sorry. Control C, dismiss this, Control V. That's what we did in the static. And I'm trying to discourage this process. Go copy the query that was used to generate this value, dismiss this value, and put the query in that position. That's how you make your query dynamic. This is dynamic coding. Right. So at any given moment, the system will run this to do what? To investigate the average list price, average overall list price. That is the part that was missing in that question. Everything in this question, we can obtain it, but now the condition. Give me a list of all employees whose salary is less than that of Idris. What is Idris' salary? We need that information. That's the investigation we are doing here. What is the average list price? You need to do that investigation. And based on the exploration, this is the query we built to investigate the average list price. That's a value. If you take that value and just put it directly in the where clause, hard coding, right? Businesses don't like this because, of course, databases are dynamic. They keep changing. See, this is hard or static coding. I want to expose you to this terminology. As a programmer, you have to be aware of the static coding. It's when you're just adding hard-coded values into your code. Things that are supposed to change over time, you hard-code them. This is not changing. You see, it remains fixed. Right? But then if you embrace this strategy, that's a query that runs to fetch that value. Right? So this is dynamic coding. I need to introduce you to these terminologies. So this process is dynamic. Whatever the average list price is, the system will investigate it by running this query against that table of interest. Remember, once you know your database, you can dismiss this part. I think that should not confuse you. Right? So this is dynamic coding, and this query will always deliver. So remember, the innermost query always run. This is the child query. This is what we call the subquery. This one right here is the parent query. The parent query is showing us all product information. How many products do we have? We have 504 products. You see, of these 504 products, how many have their list price greater than or equal to the average list price? So first, what is the average list price? This is the investigation right there. We use one separate query to investigate that unknown to get the result right there. Now we pass that unknown to the outer query through this connection. This is a parent query. This is a child query or the subquery, and this is the umbilical cord. Right? When you're doing this connection, you have to be careful. You have to know what this is returning. This right here, so that you pass that information to this. The question says products where the list price is greater than or equal to average list price. This is where list price greater than or equal to, what are we fetching right here? Average list price. Now we combine the parent and the child query. This is the final outcome. Out of 504 products, 136 products have their list price greater than or equal to the average list price of the products. That's how you solve this question, right? I want to stop right here. I don't want to go any further until we have a green light from you. All right, let me stop right here. Process this. All right, ask questions. Let's address them. Understand why I discourage this one, hard coding, and I'm strongly in favor of this one, dynamic coding. So let me stop right here. Questions?
I have a question.
Yeah, question.
In the subqueries, right? Can we only include them in the where clause, or like?
Yeah, and that's a very good question. Yeah, so I'm going to show you an example where we can put them on the select clause. You can put them right here. And then next week, we're going to see an example where you can put them in the from clause. That's what we call a derived table. So when your subquery is placed in the from clause, it's a derived table. Right. So I'm going to show you two today. The first one is what we just did, where the subquery is targeting the where clause. It's placed on the where clause to facilitate the condition. And then another scenario where you can put it on the select clause to build a column. Right. We're going to see these two scenarios today. And then next week, when you place a subquery on the from clause, it has a different name. It's called a derived table. See that? Let me just go ahead and show you an example. Yeah, but we're gonna get to that. So this right here, execute. I have this. Right. This now constitutes my. I can put this together and go above this and do select star from. Now see what I'm gonna do right here. We talked about one key characteristic of a subquery. It always needs to be enclosed in a set of parentheses. You see that this one now is at the from clause. This is what we're going to study next week. This is a subquery turning what? An entire table. And so you can now put this in the from clause. You know, the from clause carries tables. So this is a subquery which runs and generates this table. Right. And the only next thing we have to do is, if you're placing a subquery on the from clause, that subquery should have a name. So you have to call this as, for example, T1. Let's call this table 1. So this right here will execute. And what are we doing? We are selecting all the data from T1. If I dismiss this and I say select star from T1, I get an error. What is T1? T1 is not known. But my T1 was defined by that inner query, that subquery that I've dismissed. So let's back up a little bit so you understand this fully. This is us selecting star from T1. And our T1 is defined by this. So the system generates this and store it in a virtual table called T1. T1 does not exist anywhere on the Object Explorer. It's just some virtual construct. That's why when you dismiss its definition or the query T1 becomes useless. Select star from T1. What is T1? T1 is useless. So this is what we're going to see next week. People call these advanced topics, but it's just simple things that we've studied. We are now presenting them differently to give you flexibility. And I'll explain where this flexibility is used in problem solving. And usually I like to indent so you understand that the outer query with select star from and your inner query, which is a subquery, is now providing you the table, this table, which we've stored it under T1. Right. So this is a subquery in the from clause. This is called a derived table. It is usually treated separately. So that's what you're going to see next week. Let me not confuse you. I'm going to dismiss this one. Right. But that was a very interesting question from Alex. Yes, I will come back to that version where a subquery can go into the from clause. In that case, it constitutes what we call a derived table. Today, we're going to see a subquery within the where clause of the parent. You have to understand this parent-child connection. The parent is the main query, this one. The outer one is the parent query. The child query is what we call the subquery or the inner query. So some people use these names interchangeably, so you have to understand. Right. Okay, let's go a little bit further on this. Let's take our question 1. Please just do me a favor and change this. I forgot to update this database. We are now in 2022 for the AdventureWorks databases. So just update all of those to 2022. So as to clear that error indicator. So let's look at this. So let's look at this question right here. Write a query to retrieve the product information details for all products with weights above this. Nothing is hidden in this question. In fact, this is where we're supposed to start this process. We are used to this kind of question. Everything is known, no hidden components of the question. We know exactly the value to put in the where clause. It's going to be this. This is not hidden. You see that? All right. I want you to be able to see those questions that carry a hidden aspect and those questions that have everything open. You just need to plug them in. All right. So we're just going to plug this value in the where clause for weight, where weight above or where weight greater than this. Nothing is hidden. And this is it exactly right here, where weight greater than the value that was provided. See, straightforward. We don't need more than one query to solve this. One query can target that question and we're done with that. And this is the kind of things we've been solving since the first 1 to 7 weeks of the training. All right, but then we want to step this up a little bit. All right, we want to take it to the next level and show you questions where you will need more than one query to solve them. And that's the concept right here. Write a query to retrieve product information details for all products with weights above the average product weight. This question is different from this one. In this one, the targeted value was provided. Nothing will be investigated. Just plug that in one query and you're done. You cannot do that same thing right here. Why? Because the value we are targeting in the where clause is not known. We have to investigate it. But what is the average product weight? That's a key part we have to know before we can solve this question. What is the average product weight? So I'm trying to highlight those scenarios where those business requirements where you need to read through and say, hey, now this particular one, I need to use a subquery. I need 2 statements to run and then figure out a way to combine the 2. I need to investigate a missing part of the question. This missing part will be addressed right here. What is the average product weight? This will become our child query. Some people call it the subquery. And this is the investigation we are doing right here. Please just do me a favor to change this to 2022. So this is us investigating the average product weight right there. And that's the value. See, if this value was provided to us, like what we had in this question, just go ahead and plug it in and solve it. One query, you're done. See? Right, but if the value is not provided, See, you have to begin that question by investigating. So this is what is going to constitute our child query or the subquery. Right, that's it. And then now what we constitute the parent query. So I'm just going to put all of the names: child query. Some people call it inner query. I want to expose you to all the names: inner query. This one goes the inner one, just like in functions. This is a inner function. This is the outer function. So the system runs this first and then brings in this one on the output returned by this one. Right. So you have to know this terminology. The child query is also referred to as the inner query or subquery. Meanwhile, the parent query, it's simply now the outer query. So you have the parent, some people call it main query. Let me just put the key names right. The outer query, some people call it main query. All right, those are the possible names. I'll just switch this to 2022. So since we're looking at a list of products that have weights above the average product weight, this will just be the products we're getting, all of them 295. That's the parent. The child query will now come in to help reduce or impose a condition. Now, this is the static stuff again. We talked about static coding, right? And this is the dynamic one. This is what I want us to focus on. So this is our parent query, giving us the list of all those 295 products. This is the child query or the inner query, investigating the average weight. That's the investigation right there. And of course, take note, the inner or the subquery or the child query must always be placed within a set of parentheses. If you exclude that, you get an error. This is already an error. You have to understand this. Very important. So you must enclose your inner query or the subquery within a set of parentheses. This is the investigation right here. This is weight greater than average product weight. So give me all products with weight greater than the average product weight. And now if you put the two together, the parent and the child combined together, we solve that question. Subqueries are very interesting. Right. Okay. Any questions so far? If not, let me just go to HR. Let's look at one example so that we can clarify this further. So list of employees in the same department as Nancy Greenberg. Of course, there's an investigation we need to know. We don't know the department of Nancy Greenberg. Let's investigate that. If I told you that her department, there's nothing to investigate, just write one query and solve it. But since the department of Nancy has not been provided, we need to investigate her department. This is very important. If we're told that Nancy's department is department ID 100, this is the code you write. See? But we're not told. We need to investigate what is Nancy's department. So that's going to constitute our child query. Please take note, the hidden aspect of your query should be treated with a child query. The main part of the query is to what? List all employees. That is the parent side. The child side investigates the missing piece in your business requirement, and which is very crucial. What is the department of Nancy? Imagine you were given this question. You have, I don't know how you proceed to solve it. Maybe that I was supposed to challenge you on that, to see how you solve it. Right. So this is us attempting to investigate Nancy's department. So all I'm interested in is just her department ID. See that's all I need. Right? And how can we make sure that the department ID we have in the return outcome will be that for Nancy? We are putting a condition where the combination of the first and the last name with the space in between, like you see right here, is Nancy Greenberg. This is the investigation. Right. Without that investigation, I'm just getting every department ID. But if I add that condition, I'm making sure that this is definitely Nancy Greenberg's department. See that this is very important. Some other person will solve this question instead of combining the concat. They're going to put where first name equal to this and last name equal to this. Yes, that's very, very possible. I know a lot of you are thinking about that. Why is it making this complicated with the concat function? We can keep it simple. Where first name equal Nancy. Yes. Why do I also need to add the last name? Two or more persons can have the same first name. I want to make sure that we are dealing with Nancy Greenberg, nothing more, nothing less. So first name equal to Nancy, right? And I also want to make sure that we deal with the last name. Two or more persons can have the same first name, right? So if you're a fan of this approach, if it makes more sense, then we are still in good terms, you see? We are returning the same. So if this is tricky, but I like to expose you to multiple strategies. What makes a data analyst is your flexibility when it comes to strategies. There are several ways to solve equation, right? The more of those strategies you know, that's how you're building your skill set, right? So if you relate with this one, fine. You have to understand why I'm going for first and last name to make sure it's actually Nancy Greenberg. So that's the investigation, and the only thing we want to return or know is the department ID of that person of interest. You see, if you go with this one, fine. So these are the two possibilities. Let me share this one so you can add it to the code. Whichever one works for you, please be my guest. Go with it. See, right? I know most of you will relate to this one, and you have to understand why we are using an AND operator right here. Right? We want to make sure it's Nancy, and we want to make sure it's Greenberg. See? So this constitutes our child query. That's our investigation of the unknown. Now we are good to go. We can now combine the parent and the child. See, the child goes, in this case, we are targeting the where clause. So this is the investigation we did. What is this returning? It's returning the department ID. And you also have to know how to build the umbilical cord. If this is returning department ID, the receiving column on the parent side must be department ID. You cannot equate cocoyams and plantains. See, this is where students get it confused. When it comes to building the connection, this is your parent query, it's getting all employees. Your child query is limiting the employees to only those in the same department as Nancy Greenberg. So what is the child query returning? Department ID. So what connection should we be putting right here from the parent side, the department ID? This is very important. And now combining the two together, this is the full list of all employees who are in the same department as Nancy Greenberg. Nancy herself is included because you see that department ID is there. This, and this. See? So these are the full list of employees in the same department as Nancy Greenberg. Stop right here. Questions? I'll stay on this HR one. I want to add one more question to this. So while you're exploring that and putting together equations, if you have any, I will use that salary stuff. List of employees. I'm going to target a particular. So we are still on HR. Use HR. On HR, we have two tables that I would like to focus on. Let's get the employees table and the departments table together. Okay, I'm gonna use that same Nancy's example. So we're gonna get the list of employees with salary less than the salary of Nancy Greenberg. So that's the new requirement right here. I'm still gonna be using the employees. I'm gonna put it right here. Last time we talked about department. So this time around, I want us to do list of employees. This time around is going to be salary, list of employees with salary less than I need somebody to volunteer and solve this question. You have to understand this one. In the scope to salary, you're able to solve this one. So list of all employees with salary less than that of Nancy Greenberg. Right. Again, the subquery will be, what is the salary of Nancy Greenberg? What is the salary? This is where the investigation begins. What's the salary of Nancy Greenberg? So given this right here, we have to investigate the salary of Nancy, and this will constitute the inner query or the subquery. This is very important. So the hidden part of the question, you're going to solve that, use, and that will constitute our subquery. See, if you can address this part, that is already a step forward in the right direction, investigating the salary. So what the only thing we're interested to see in this subquery is the salary. Salary of everyone, no, salary of a specific employee, Nancy Greenberg. So we can just go get that condition we use right here. If you're a fan of this process, that is an investigation, so that we tie this salary to that particular person of interest. So this right here will give us the salary, just one, of course. That's the salary of Nancy. That is the investigation we've done. Key part to this question. Right. This has been achieved. Now this is all the employees. This is now the main query. Now if you now combine, let me just go direct. Let's just go direct now. This is the solution. Now will be this. You may be asked to give the first name for the outer query. Give me the first name, last name, the actual salary of all those employees where their salary is what? The salary is less than that of Nancy Greenberg. That's the question, right? List of employees with salary less than that of Nancy Greenberg. So what value are we going to pass right here? We have investigated that value. That salary is this one. And remember, in the context of a subquery, you must put it in square, in parentheses. And I always like to paste and then edit, because format, because if you see where this is confusion, right? So I like to indent so as to differentiate my parent layout from my subquery layout. So this right here is coming from my subquery layout. So I have to indent. Right, so anybody reading this will understand. This has nothing to do with the syntax, either it's going to fail or execute. If I stop right here and execute this, it's going to go through. But I bet you people will have a hard time understanding what's going on. So the power of indenting comes in. Right, readability of your SQL code. Help the end user or whoever is reading your code to be able to understand what's going on. And people do this in several ways. If you can arrange it nicely, anybody reading will spot that stuff. I didn't make a mistake on this. Last time we addressed this, if you see, the things back. Yeah, this is it. So if you look at this layout on this side, that's the parent side. Then this is the child side, which is participating in defining the where clause. What employees should we see? Are we focusing on all the 107 employees? No, we are only looking at those employees where the salary is less than that of Nancy Greenberg. And this right here. So take note, we are investigating salary. When you have this dark stuff blinking, just go to, right, this is override, double click on OV arrow so that it goes to INS insert. Right, so please take note, we are interested only on the salary of Nancy Greenberg. That is the result for the inner query investigation, this value. If we were provided this value upfront in the question, then there will be no need for this investigation. That's the value that was provided. You just dump it in there and execute. So we are going to more advanced. These are things we could do at the very beginning when we did the where clause. I just give you the specific value, plug in the where clause, and you get the job done. I didn't want to stress you to investigate things, But in this case, you've been able to handle this pretty much very well. You deserve to go to an extra level, a higher level, and that's the higher level right here. The value to be investigated is not directly provided in the question. You can investigate it using a subquery. That's the whole scope of this part of the lecture. Don't go grumble, hey, Nancy's salary was not provided, the question is incomplete. No, you can investigate it. And that's the goal of this segment. Investigating the unknown parts of your business requirement, addressing it using a subquery, and then incorporating that investigation into the main query, and together we hit our target. So out of the 107 employees, there are 98 employees who earn less than Nancy. And I can even go ahead and continue with the outer query by adding an order by. This order by goes to the outer query. Let's order by the salary. See, let's sort these employees by ascending order of the salary. See, let's run. See, the idea of indenting helps this layout. See, and this is it. Let me share this with everyone. Please add this to the requirement below what we had for the department. So this is salary one. Previously we did the department one. And I think we should take a break so you can allow this to sink in, and then we're gonna get to a multi-valued subquery. That's when your subquery returns a single value in a multiple values. Take note, in all the subqueries we've done, if you highlight them and execute, you get a single value as the result. This is what we call scalar subqueries, when the subquery returns a single value, one value right there. Let me just review this before we take a break. Go back to all the subqueries, execute them. They all return a single value. This is what we call a scalar subquery. All our subqueries we've done so far, this investigation right here, I need to switch this. This goes, yeah, anyway, that's fine. Switch this to AdventureWorks. I think I'll encourage the habit of coding the table inside so that we avoid switching things left and right. I think by now you understand. So this can run even though I am currently on HRO. This investigation can still go through because I've specified AdventureWorks Ltd on the from clause. So you see all of these investigations in the subquery, they are returning a single value. There's a name for this, scalar subqueries. See, I think I put that in the top. Maybe we missed that. Let me go back so that we can now transition. That's A, focus scalar subqueries. Subquery returns a single value. After the break, we're going to go to B, which is what? Multi-value subquery. This is the B part right here. So in this, the subquery returns more than one value contained in a single column. Right. not multiple columns. We have one column with multiple values. That's what we call multi-value subqueries. We're going to address this after the break. Okay, I think we deserve a 20 minutes break. Let me set a timer for a 20 minutes break. Okay, see you after the break. Okay, are we back? Okay, any question before we resume? So the second part, we're going to be looking at the multi-value subqueries. So from the name, these are subqueries that will return multiple values, and you have to remember they should be in a single column, right? So let's take an example. So list all employees in the same department as the following. So last time we focused only on Nancy. This time around, I'm going to add this and this. So it's the same logic, but then what changes is this. Notice that the investigation is now based on 3 employees. And of course, these 3 employees have 3 different departments. So we are now moving from a single value in the subquery to multiple values. And that's a list of values. First of all, let's run this. So we're using an in operator right here. We list the employee names and we investigate their department. So this is the subquery investigation for that. These are 3 departments returned. And this is very important. You cannot maintain an equality right here. So if a single value is being used for the investigation, then you can get an equality, like the case we did for this right here. The single value was investigated. All right, that's Nancy's department. We get just 1 value, department ID for Nancy. We can use equality right here. But if the subquery returns more than 1 value, then that becomes a list. And so the in operator needs to step in. All right, this is very important. So if you maintain an equality right here, you will get an error. Let me just execute this so you can see what we get as error message. The subquery return more than 1 value. See, this is a subquery. Upon execution of a subquery, we get more than 1 value. See, this is a single column with more than 1 value. That's a multi-value subquery. So whenever this happens, you must use an in operator right here, since the subquery is returning more than 1 value. So this is like a list of values. So is equivalence of me dismissing this. See, dismiss this, and then go in and manually type the department IDs that were returned by the subquery. This is, and of course we can remember this is a job of the in operator. When you have multiple values, the in operator steps in. Equality no longer works in this situation. You see, this is very, very important. Yeah. So this is in operator. We have a list of values to look up. This is what we get. So this is hard coding. We have to investigate the departments of those 3 employees and place them in that subquery environment. This is an investigation. Now this is the full picture. This is a list of employees who are in the same department as those 3 employees. Now this is the full picture of that query. See, the 3 departments were 100, 50, and 80. And those are the 3 possible values right there. Right. So this is what we call a multi-value subquery. More of these definitions, I think you can see them. Okay, sorry, I don't have that material. But on this slide, you can see those definitions. So scalar value subquery, multi-value subquery, and know what to do in connecting the 2, the outer query, the parent, and the inner one. So once the inner query returns multiple values, there should be the connection. Right. Okay, let's take another example on this. List all employees in the IT department. So since there could be more than one employee in the IT department, you're dealing with a list of values, right? So they want us to return employee ID, first name, last name, job ID, salary, right? These are two tables in this question right here. I can use a subquery or you can use a join. So there are two ways to proceed in this. Do we need a join in this? We can need a join if we want to show the actual names of the departments. But from this, we just need the employee ID, first name, last name, job ID, and salary. All of this information can be gotten from just the employees table. Right? Yeah, this is very fine. You see, but then see what we have: IT department. If we stay on the employees table alone, we will not be able to trace the IT department. The employees table only offers us department ID. So how do we know the department ID of the IT department? So we can use this table right here for the simple investigation. Let me begin by showing you what you do without the subquery knowledge. You just simply proceed by joining these two tables. Why? Because we're going to need the department table to identify the IT department. Right. So if you go to the department table, this is it. So the IT department is department ID 60. So you can solve this question first by joining the two tables so that your where clause will carry where department name equal IT. And you end up listing the employee ID, first name, last name, and job ID and salary for employees in the IT department. That explanation is what is carried in option 1, the join approach. Target the two tables and join them. This is the employees table, inner join the department table. So by joining these two, we have now access to the department name from that department's table so that we can make it equal to IT. And so this list right here will be the list of employees in the IT department. So that's the join strategy. See that this is what most of you will do, right? This is a strategy involving a join. I get the two tables, join them together. Why do we need a department table? Because of this condition. You cannot stay on only the employees table to get this. Employees table only gives you the department ID. Right. Now, if you don't want to join, you can say, hey, you know what? I'll use a subquery. What's the strategy? Investigate the department ID of the IT department. And you stay only on the employees table. You see, my parent table involves only the employees table. That's the parent table right there. Only the employees table. Right. Now, my department table is used in the subquery because we need this condition department name equal IT, and then give me the department ID of the IT department. You have to make sure you're returning a column that can be identified by the outer query. Can somebody explain why we cannot return department name? Right, because if I put this query to return the department name, I get this is the IT department. See, but guess what? I will not be able to connect that to the parent table because the parent table does not recognize IT department. It doesn't have a department name column. So you have to link the parent table to the child table on something they can both identify. Department ID is found on the employees table. See, I can put where department ID from the employees table is equal to the department ID. So that's why I use ID on this side. The department ID from the department table. These are two different tables running on two different select statements. Easy, we just join them together, and that's a join option 1. Option 2, investigate the department ID from the departments table and make sure that the ID returned is the ID for the IT department. This is the investigation right here. So this is the department ID for the IT department. Now, the parent query which runs on employees table can identify that information. You can now put where the department ID is equal to the value returned by this one. See, this is it. And that's how you put everything together. These are the employee information of those who are in the IT department. And this, see that? So you can choose whichever strategy to proceed to solve this question. The only limitation to option 2 is if you are asked to add the department name. See, if I copy this department name and add it to the return on the parent side, the system gives me an error right here. Why? Because my parent query is this one. It is strictly on the employees table. There is no department name on the employees table. This fails, see? Now that's the only problem with this subquery approach. So you must make sure that you're only specifying columns that come from this table on the parent side. But if I go to the option 1, the joins, once you've joined two tables, yeah, you can call any column across the two tables. You already joined them. I can go to this list and add the department name. The system is going to accept it because as long as I have employees joined to department, I have access to all columns in the employees table. And I also have access to all columns in the department table. This is it. So I can update that. So I can update that query to now give me the department name as well. You see, everything is IT department. See, so the strategies, they have their limitation. The power of the join is if you succeed to join two tables, advantage, you have access to all columns across the two tables. See, we did not join the tables in the subquery approach. Our parent query ran strictly on the employees table, and then our subquery ran strictly on department table to return department ID, which is then passed to the outer query to complete. See, this is built to receive the department ID that is pushed by this one. That connection is very important. Right. So the choice is yours. If you want to solve this question using the join approach, or you want to use the subquery approach, right? You see, both are yielding the same result. That's option 1 and 2 executed together and placed. Right. They are all yielding the same result. See that? Right. Any questions so far? Okay, let's take another example. I will need you to go back to week 7, day 1 and execute the Yelp database script. We need that information to solve this question. So this is week 7, day 1, this database script right here. Please open this and execute. It's one of the questions from this website. I'm going to show you the website. So let's first of all open that database script and execute. You find that in week 7, day 1, it's right here. Execute. Right, so it successfully executed, shut down the script. You should have a new database. And just go back and refresh right here. I think we are dealing with just one table. Let's see what tables we have. I think it should be one table. So why this is loading, let me show you where I'm getting that question. It's from this website we've been using. Go ahead and execute that database script. Make sure shut it down once you're done with the script. Let me see if I can identify the question on the list right here. This one is okay. This one needs some subscription. Yeah, anyway, I have the question right here. Top rated business. So before it was exposed, but now it's been blocked. You need to do some subscription, but that's still fine. I have. So this is the question right here. Why is this still? Okay, let's check out the question. Just permit me to shut down my management studio. I'm having some issues. So I'm going to shut that down and relaunch it again. While waiting, just go ahead and do a select star, connect to the EF database, do a select star from that reviews table, and just explore the table why I put this together. Okay, so we're looking at this. We have executed the database, so we should be okay with this. So if you're seeing this for the very first time, you could just take that to Google and run this so that you can understand. It's a platform that customers go and do reviews on, customer reviews basically. So the Yelp is an American company that develops this app website and this mobile app, which publishes crowdsourced reviews about businesses. It also operates this, so it's basically a a platform where you can go and review a company. A company can render services to you, and you can go write a review. Some people are really brutal on this. They write very crazy reviews about companies, But it's just an open, like I say, it's an open source, it's a crowdsourced platform. And so that's why we have access to the reviews table, right? Sorry guys, I apologize for this. My system is really, really slow. Okay, just to connect to database, it took forever to execute. So this is the table we have, the reviews table. I'm going to execute that so that we can have a print of it. So we have the business ID. So this is the company being reviewed, and this is the ID of the reviewer. This is the stars they gave, right? and this is the date the review was submitted. See that? So it's a very simple table. Now let's go and read the question and see if we can make sense out of it. So assume you are given the table below containing information on user reviews. Right, that's the reviews table. Write a query to obtain the number and percentage of businesses that are top rated. And it will go further to say top rated business is defined as one whose reviews contain only 4 or 5 stars. So for you to be a top rated business, your company should be reviewed and obtain a 5 or a 4-star rating. So we have to first of all stop right there and make sure we impose a condition which will dismiss all those reviews that are not up to 4 or 5 stars, because the focus is for top rated businesses. And the business is top rated if it has a 4 or a 5-star review. This question is focused on the top rated business. That's the title of the business objective, top rated businesses. So if you look at right here, the first thing I did was introduce a where clause to make sure we are only focusing on those companies that got a 4 or a 5-star review right here. Right. And then this right here is simply counting it's simply showing those the business IDs, count of business IDs that have 4 or 5-star review. This is it right here. I'm going to explain why we're doing this. Right. And if you want to see the full list, you can just dismiss that asterisk and run this condition. Right. And I want to make sure that these businesses the IDs are different. So this is what we are supposed to focus on. Right. Now back to this count. This just does the count. We're counting the businesses 1, 2, 3, all the way to 9. So these are the 9 businesses that have a 4 or 5-star review. Okay. Now let's go back to the question. So what are we supposed to do? We want to output the number of businesses. And what is this number? It is a number we've computed right here. This is the number of businesses with 4 or 5-star review. That number, that's it right there. So number of businesses and percentage of top rated businesses rounded to the nearest. Number of businesses and percentage. Right. So number of businesses and the percentage. So how many businesses were rated? How many businesses were rated? We have to dismiss this one and look at this. There are 12 businesses in total that was evaluated. Of the 12, 9 are 4 or 5-star. These two numbers are important, right? Because to get the percentage, you must use the specific portion relative to the overall. The specific portion is this part right here, relative to the overall, which is this part right here. But now notice if we just go into the query, let me show you the mistake we can do before I get to this. Now this is the total. Where are we getting this 12? This 12 is the total number of businesses that was reviewed in that table. The original table has 12 businesses reviewed. Right. How many of these 12 businesses are top rated? That's have 4 or 5. This is the count right here. There are 9 of them. 9 businesses are top rated. So what is the proportion or the percentage of, that's the question. Output the number of businesses and percentage of the top rated businesses. So that percentage calculation will be the number of businesses and this, since this condition involves this, we are looking at this count will be the count of the top rated businesses. That's the 9, this number right here. 9 top rated businesses. And what is the percentage of the overall 12? So you have to take that number, divide by 12. But then this is hard coding. See, what if more businesses are added to this reviews table? That number is no longer going to be 12. See, all right. So we are basically looking at the percentage of the top rated businesses relative to the overall. So you have to take the 9 companies that are classified top rated business, divide by the number of reviewed companies, which is 12, and then you multiply by 100 to get the transform as a percentage. See what we're doing right here, right? So we showed in the number of top rated business. This is the first part of the equation. This part, output the number of businesses. This is a top rated businesses. So this number right here should be the number of top rated business. This one. That's what you should show in the first number of top rated business. And then the second one is the percentage. How do you calculate the percentage of something? The thing divided by the overall multiplied by 100. So this is what we're doing right here. Take the percentage of top rated, the number of top rated businesses. You have to understand that this condition is playing a role on this. This count goes with this condition. So this is the number of top rated businesses. Divide by the total number of businesses, which is 12, and then multiply by 100. That's how the percentage is expressed. And the fact that this is present, this is influencing the count. Right. So I have to make sure that this 12 right here is not being influenced by this condition. So this 12 right here should be the total number of business. This one right here. You see, it doesn't work. It doesn't rely on the where clause. This is the number of top rated businesses. Any business that has a 4 or a 5-star review is top rated. There are 9 top rated businesses in this analysis, and there are 12 overall businesses. So the percentage will be what? 9 divided by 12. But you notice that if you want to use a single select statement, this condition right here impacts this calculation. And also it will impact the calculation we put right here. So we just went for the 12, but then this is not the way it should be done. So if you read right here, it is not a good idea to place 12 in the denominator of the percentage of the top rated business. What is a percentage of top rated business? Is a number of top rated businesses divided by the overall number of businesses. So 9 divided by 12. You have to understand that the reason why you're getting 9 in this count is because of this condition. Those are the companies that have 4 or 5-star reviews. Those are the top rated businesses. This is the count right here. But then this count should involve every other company, not just these ones. So how do you do that? This is a question that goes back to Alex. This is the question you asked earlier. This is now a subquery which we've used in the select. Previously, we've been looking at questions where the subquery was implemented on the where clause. You have to understand that this denominator should involve every company, not just the top rated one. A percentage is what? The specific portion you're investigating divided by the overall, multiplied by 100. The denominator should capture the overall number of businesses. And this is that overall we have right here. So there are 2 parts to this. Our goal is to take 9 and divide by 12. The 9 part is what you get right here. There are 9 top-rated business. A top-rated business is any business that has a 4 or a 5-star review. This is it. 9 of them. How many businesses were reviewed in total in this particular analysis? There were 12. I have no condition on this. So I have to take 9 divided by 100 multiplied by, 9 divided by 100. 9 divided by 12. And then we multiply all of these by 100. If you want to get it as a percentage, you need to do that little adjustment right there. And this is it. But then the issue right here is this. Right, this is decimal. If I do this, see, I get a decimal out of this. I also get a decimal out of this. Right, this will give you some very meaningful result. Right, but if you just take this divide by this, let me show you this, it gets 0 point something. The whole number version, the integer version, will not give you that concept. It will just, see, the answer you're targeting when you divide 9 by 12 is 0.75 something. But since this is the integer, it sticks to 0. I want you to understand why SQL is giving us 0 when we do it like this. Right, this is very important. See, and so the way forward to proceed is to take the 9. This is what data analysts take, the 9 and multiply by, that's to express in the percentage form, multiply by. Some people can do 9.0, 1.0. Take 9. This is just a way to transform the numerator as a decimal. If you keep track on this, you get 0. You're supposed to get 0.75. But since numerator is in a whole number, denominator is a whole number, you get a whole number, you're not going to get a decimal. So instead of 0.75, it just gives you 0. But if you transform this, if you multiply 9 by 1.0, you haven't distorted. You're just now working on more like the data type. And this favors the calculation. You see, we have our target. Just this little maneuver you do right here. Right. So some data analysts do this in order to, but then this is the official way to do that process. You have to target 9 and cast it. Right. So cast 9 as a float. Float will allow decimals. Right. And then don't bother about the denominator. You just need to cast one of them. You see 0.75. But then this one also delivers. Take the numerator and multiply by 1.0. It's a way to transform this 9 as a whole number into decimal. Decimals have power over whole numbers. See what you get. See that? So I want you to understand that the percentage of top rated business is the 9 number of the 9 divided by 12 multiplied by 100. How do we get the 9? You see, in that calculation, you can see right here. The top rated businesses are those that have 4 or 5-star review. This is the counting process involving that you get 9. What is the overall number of businesses that were reviewed? 12. This count is the general. It doesn't involve any condition to eliminate. So you now take 9 divided by 12. But if you start putting this together in a SQL query, as long as this condition is present, it is influencing this count on the numerator. It will also influence this count on the denominator. So basically you're taking, so let me show you what this is giving. It's giving you 9 divided by 9. If you remove this, somebody will say, why don't you remove that 12 and make it dynamic and you put this? The two and the denominator are the same. Why? Because they are all tied to this condition. This is 9 divided by 9. They are all tied to this condition. So the problem in this question is to make sure that this denominator is not tied to this condition. It should always give you the total number of businesses that were reviewed. That's 12. That's the major issue. So that's why I started by showing you the hard-coded version. Then now transform this into a subquery. Now this is where the fun part begins to see. This is the total number of businesses that was reviewed. This is it. You see that this calculation does not involve a where clause. We are considering all the businesses that were reviewed in that table. Execute. That's how we get to 12. See that? In this one right here, this count is tied to the parent query, and the parent query has a where clause. So this count will be a count of 9. Why? Because it ties to this condition. So it is similar to what we have right here. The counting you see right here is tied to this condition. If I dismiss this condition, I get the overall businesses, which is 12. This is what I want to be in a denominator. If you review 12 companies, 9 are top rated. What is the percentage of top rated businesses? It is the 9 divided by the 12 multiplied by 100. That's the logic. But then if you want to use a single statement to solve this question, you will never be able to achieve it, because the presence of this condition influences this count and restrict it to what? 9. This is correct. This is what we want in the numerator. In the denominator, if you still go ahead and quote count of business ID, it will still give you 9. You're basically taking 9 divided by 9 multiplied by 100. This is wrong, right? So we need 12 in the denominator. And how do you code that? You must run a separate query which has no condition, so that we consider all the 12 businesses that were reviewed, and this is what you get. So this is an example of a subquery on the select clause. Remember, I promised you 3 ways of presenting a subquery. We've done the first one today. Popular one was a where clause. All the subqueries we've studied, they were all placed on the where clause. The second one I'm trying to show you is the one that is placed on the select clause. So this goes to the denominator of a calculator, of a calculation. Right? Our numerator should be the number of top rated businesses, the 9 we saw because of this condition. So it influences this. The denominator should give you the total number of businesses. So that should be a separate process. You see, this count does not involve the where clause. So we've carefully isolated it so that we get this. But this count right here is impacted by the where clause, which makes this the top rated businesses, the 9 we have in the numerator. I hope this makes sense. And then to transform this as a percentage, we are multiplying by 100. So we show you the number of top rated businesses, and then the percentage of top rated businesses is the number of top rated businesses divided by the overall businesses that we review. So you have to watch out. This could be tricky when you're solving this kind of questions, right? The condition right here impacts whatever counting you're done. It impacts this count. It impacts this count. For us to make this counting right here to be independent of this condition, we have to run it on a separate query. That's exactly what we're doing right here. So this runs on a separate query and gives this. Please take note, this condition does not impact this. This is subquery. It runs independent of the parent query. This one right here is part of the parent query. This count is part of the parent query. This count is from the parent query. This count is subquery. If you have maybe 10 subjects and you pass in 9 of them, this is the 9 you've passed. What is your percentage pass? Is the 9 you passed in divide by the 10 total subject you sat in. See? So this counting at the denominator is the general count. And that's how you can achieve a subquery. Right. I want to stop right here. I want to make sure this is understood. I need your feedback. Is this question understood? We're asked to show the number of top rated businesses, first output, and the percentage of top rated businesses. And we have to round this to the nearest integer. Like, how do you get the percentage of the top rated businesses? The number of top rated businesses divided by the total businesses. 9 divided by 12. Right. It will be tricky. What can you do to the denominator to keep that number overall? Prevent it from being influenced by this. So that should be a separate query right here. A separate query runs and generates that. Is this understood? There's a lot of silence. I want to make sure we understand this. This is a repetition of things we've done above.
All good on my side.
Okay. So so what we just saw is an example of a subquery on the select clause. This is our select clause, and then this is a subquery right here. It's present in the denominator. Possible locations of a subquery. Select clause. We've seen another example, subquery in the where clause. These are examples. You're familiar with these ones. This is a straightforward question. Write a query to retrieve the product information details for all products with weight above this. We've seen this one. It's just plucking that weight. There's nothing to search. The value is mentioned. In this one, the average product weight, the value is not mentioned. You have to investigate. So we use the child query to investigate the average weight. Right. Let me just switch. The database is this. Right. This is just a repetition of what we've done. So we investigate that average weight. Now we can put it together with the parent query. Let's combine the parent and the child. This is a parent giving you all the products. We are interested in those where the weight is above the average weight. So the investigation of the average weight is done through a separate statement. That's the child query right here. Putting this together, this is the list of products where the weight is greater than the average weight. For example, right here, give me the first name, last name, job, ID, and salary of the employee with the highest salary. So I'm going to give you two possibilities, the top clause. Right. For you to use the top clause, this is what this means is you have to sort. Right. Since we're looking at salary, let's sort all the employees based on salary, highest to the lowest. This is it. This runs on HR. Right. So first we sort based on salary. So we have this sorted list. We see the employee with the highest salary at the very top. How do you extract just this person? That's what this question was, the highest salary. Employee with the highest salary. This is it's a top one. That's the top clause. Put top one. Don't just see a query and just put top one. It must be based on some criteria. Since we are looking at salary, we order by salary, then we now put top one. We know that the top one will be the employee with the highest salary, and that's the person right there. Alternatively, you can actually use a subquery to investigate the maximum salary. You see this investigation, right? This is a subquery approach. We are using the max function to investigate the highest salary. This is returning the salary. This is the highest salary in the company. If your salary is equal to this, then you are the person with the highest salary. Then we can now show you the first name, last name, job, everything of that individual whose salary is equal to the highest salary in the company. So if your salary is equal to the highest salary in the company, then yes, you are the individual or the employee with the highest salary. These two strategies are easy. I like exposing you to strategies. That's what makes you a data analyst. Your flexibility to solve questions. And it builds your experience as well. So some other person will reason it from this perspective. Let me get all the employees and sort them based on salary. You see, salary descending, highest to the lowest. I have this list. In this list, I'm not interested in all 107. I'm interested in the first person. That's the person with the highest salary. And how do you extract the first row in T-SQL top one? Now, this is the employee with the highest salary. That's the conclusion. After you've sorted the first person on the list has the highest salary. We've sorted by salary. We are confident with the sort process, you see. And that's the extraction right, the top one. Some other person will say, you know what? I'll use the max function to investigate the highest salary. Any employee whose salary is equal to that highest salary, then obviously you are the employee with the highest salary. That's another strategy, another angle of looking at this problem. You just have to sit back home and review this. Please focus on the logic. Problem solving has to do with strategy. What is your logic? Right. This is very important. So these are the two ways. Maybe there could be other ways, but these are the two easy ways you can navigate that. Let's look another one. From the following table, write the SQL query to find those employees who earn less than the employee of ID this. You see, they did not give you the salary of this employee, they gave you their ID. So you need to run a subquery which will investigate the salary of this employee. And then now you're going to bring in that parent query to now list all employees whose salary is less than the salary you investigated of this individual. That's how you flow on this. So I'm trying to build that capacity for you to read a business requirement and understand that there is a hidden agenda that needs to be investigated. And those kind of stuff have to be solved through a subquery. That's the goal. Right. We are now looking at those indirect kind of questions. Right. I'm gonna skip this part of self-join. This is a subquery part right here. So this is us investigating what the salary of the employee with this ID. See, because that was a question. Employees whose salary who earn less than the employee of ID this. The employee of ID this, what is their salary? This is the investigation right here. Investigate that value. This is it. We then take that value and pass it to the outer query. Give me first name, last name, and salary of anyone whose salary is less than this salary returned by this from this employee from this investigation. That's how you solve this kind of question. It may look tricky, but the power of the subquery comes into rescue. You see? So please, you have to read this and understand how to leverage the power of the subqueries in problem solving. This is very, very important. You will see in all these questions, there's a hidden part. You cannot proceed without knowing that hidden part. It's talking about salary, but they don't give you the salary straightforward for this individual. They give you the ID. Yeah, you can use that ID and investigate the salary. This is the investigation right here. Anybody whose salary is less than that targeted salary, that's the people we're looking for. And now you two queries put together, we have a parent query and a child query. They deliver the result easily. Right there. Right. So I want to expose you to multiple examples so that you can see. There's another one. Write a query to find all employees who work in department ID, this or this. With this right here, you can just join the two tables. And why we join the two tables? Because we will need to show the department number and the department name. We've had this conversation before. If we're not asked to display department name, you don't need to join. You just need to stay on the employees table and you have everything you need for this question. But the fact that we're told to demonstrate or show the department name, it means that the department table needs to show up. So when we join the employees table and the department table together, we have access to all the columns. You can show department name. So you can easily solve this question with a join. And these are the two departments we're targeting, where department ID in that hit your target. Join approach, straightforward, easy. Right. You may want to also consider a subquery where the child query will simply investigate the department, the employee IDs of all those in this department. So take note, in this kind of question where the parent query runs on a different table and the child query runs on a different table of this all employees. Yeah. So in this one, we don't actually need this is not gonna be a good example to solve using a subquery. Why? Because we are missing the department name. See how we had department name right here? If I copy this and put it in this query, I distort everything because I don't have the department table. You cannot pull a column from a table that is not listed. See? So a subquery approach for this question has serious limitation. Right? If department name was not recommended, then you can solve. I think we've seen this above, right? So the subquery approach fails in this. Right? So sometimes it's just easy. Keep it simple. Right? Just go ahead and join the two tables. Right? You have access to all the columns, put your condition, and that's it. You're done. Right? So reserve the subquery knowledge on those ones that are typically needed. So in this, you can survive this question with your join knowledge. Right? This is an attempt to solve the same question with the omission of what the department name. We need department name. This is 36 employees in this. This is 36. See, but the only difference is this one has a department name since we've joined the two tables together. That's the power of joins. It gives you flexibility. Right? And sometimes in a company, you might solve a question like this. It was given, and then they start adding more columns. You probably use a subquery. They start adding more columns, and you discover that your subquery breaks down. Right? Now you can switch to a join. See, any column you add to this list, I can pull it in. If the column is not available in this or this table, I can go fetch the table and do another join and call it in so that this query will survive no matter the situation, you see. But in a situation like this, if you look at my parent query is strictly based on employees table. So any column you want to add to this list must be from the employees table. You see that? Yeah, there's a reason I'm explaining this so that you can strategize when you have a project in front of you, strategize the best route to use. Right. Let's look at this one. Students with more than one project assigned to them. This is an investigation. We want to look at students that have more than one project. We have two tables. We have the student table, which gives you student information. Then we have the project table, which gives you project information. You can just go ahead and do a join approach. Join these two. Let me see if I provided a join approach. Let's start with what we know. If you join these two tables together, right, student and project, see the condition of added. Let me remove that condition. Let's run it. This will give you every student that has a project. This is an inner join between student and project. So what you're getting right here is a list of every student that has a project. Now, this condition right here is a condition that will make sure that the number of projects assigned to the student is more than one. That was the question. We are looking at students with more than one projects assigned to them. So by adding this condition, we are going to dismiss certain students where the count of the project is less than one. If you want to see this process, you can just add this as a column so that you can see. You put a comma right here and add this. See? Now if I run this, let me run the general one without a condition. I get the 20 students who have projects, and I'm counting or showing you the number of projects each is working on. If I switch this to a left join and my focus is the student table, what am I getting? I am getting all students, whether or not they are working on a project. This is very important. I just want to use this to review. Right. So if I run this, you discover that some students will have zero count. First thing, we talked about this in one of the projects, data reduction. Inner join reduces data because inner join is very strict. You see the previous one, we had 20 showing up. Let me run this so that you see. There are 20 students showing up, and each of those 20 students have a project. This is the focus of the inner join. For you to show up in the result, you must be a student and you're assigned to a project. Draw that. Let me draw this. This is a revision. I really want to. This is a student table. Let's take a different color. This is the project table, student project. All right. What are we looking for? We are looking for students that are assigned to projects. That is the intersection. Students assigned to projects. This is what you're looking at. See that this is data reduction. The condition is really, really strict. This is it. And that's why the inner join in this case gives 20 rows or 20 students. And if you look at the count of projects, you don't see any student with 0 project. You must be in the intersection, you must have a project. See, now if I go and switch this into a left join, I get more data. Why? Because I am also including this zone. And why this zone? Because the student table is on the left side, I am doing a left join. So all the student table will be shaded. So I have to step in now and extend the region to this. So the intersection plus all the students that have no project. So you see that this will increase. See, I'm now looking at two regions, intersection plus all the students that have no project outside the intersection. So if I run this with a left join, execute, I get the number grows up to 41. And I start seeing 0 projects, 0 project. These are things you will never see in the intersection, inner join. See, so Loughlin, for example, Priska, all the students, they are in this outer spot, this part right here. Students with no project. The students with projects, they are in the intersection. See, so this number has grown, and you see 0 counts. So if you're strictly looking at only students with project as an inner join, you do this, then you can now add a condition on the count. This is a counting process. This condition goes to the having clause. You see, it's an aggregated condition. It's a condition on the group. Greater than 1. This student will be dismissed, dismiss. We'll keep this ones, dismiss this one. Now that condition leads to this. Further reduction. And you see all these students have more than 1 project assigned to them. That's how you solve this question. That's a join approach. In the subquery approach, you can actually target. This is the subquery. What are we doing right here? We are only showing the student IDs of students that have more than 1 project. You see, I'm just focusing on the student ID. This is a list of students that have more than 1 project assigned to them. So if your student ID is in this list, then you qualify. You're considered as a student with more than 1 project. So let's go to the original student table, which gives you all the 41 students. If your student ID happens to be in this list, then it means you have more than 1 project. This is a list of students with more than 1 project. You see, I'm showing just the ID having, you see, a group by student ID. This is very important. Having the count greater than 1. These are students with more than 1 project assigned to them. And when I do this, and I'll combine this with student ID in this list. If your student ID is on this list, it means you have more than 1 project. Combining the parent and the child together, this is what we get. Same result as you would get if you went for the join route. You see, this one involves no joining. We use the student table on the parent query. We also use, okay, for the project, for the child query, we're using the project table. You see that? See, so physically, we've not joined the tables in the subquery approach. Our parent query runs on student table. Our child query runs on the project table. It is investigating students with more than 1 project. If your ID is on this list, you see it's a list as well as in operator. You cannot put equality right here because you're searching for more than 1 value. Searching for more than 1 value in a given column, it's the job of the in operator. So as long as your student ID features in this list, then you're considered to be a student that has more than 1 project assigned to them. Like these things just need practice. If you need more exercises, you'll find them right here. I want us to stop right here. Change this to 2022. You're gonna stop right here so you can address start procedures. We have 1 hour to go. I want to talk about something called correlated subquery. It's when the inner query and the child query, the parent and the child query are connected. That's the meaning of correlated. What we've covered above, these are independent subqueries. The child query is independent of the parent query. Back to HR. So these are examples of independent subqueries. If you can highlight the inner query, execute, it runs and generates a result. You can highlight the parent query, it runs, and then they're connected through this process. Right. So those are independent queries. There's another set of query which is called the correlated, where the inner query and the child query have a connection. So this is called correlated or dependent. So there is a connection between the inner query and the child query. And let me show you that connection. For example, we want to look at the order details for each customer's last transaction. So when you use max in the investigation of the last transaction of a customer, see right here, I'm using an inner query to investigate. This will give you the last transaction in the entire data set, one value. But take note, if I add this condition where the customer ID from A, table A is the table in the parent one. This is it. See, this is the parent table. It's giving you all the customer transactions. So I've referenced this as A, right? And then I go to the inner query and I reference this as B, right? So if I run just this part, I'm getting the mark, the date the last order was placed. So marks on a date gives you the date the last order was placed. If I switch this to min, it gives me the date the first order was placed. So this has to be investigated for each customer. You see, that's the goal. Order details for each customer's last transaction. Right. So by adding this condition, I'm connecting the parent query to the child query. This is what called correlated subquery. So I call a column from the parent table. You see, A is the parent table. A is coming from the parent side. All of this is called A, which is from the parent query. So I say the A from the customer ID from the parent table should be equal to the customer ID from the child table. Always remember this right here will make sure this calculation is done for each customer. That's an easy way, right? So this calculation right here, whatever you're trying to calculate, will be implemented across the two sides, the parent and the child, and this creates that connection. See, if I now highlight the subquery and execute, it's going to give me an error because I've linked my subquery, which runs on B, to parent query, which runs on A, this connection right here. But if I ignore the where clause and runs just the subquery part, would not see it runs. So this becomes what we call a correlated subquery. Whenever your subquery references a column in the parent table, see this is a reference right here. A.customer ID is being pulled from the parent table. So I'm taking the parent table, customer ID from the parent table, I equate it to customer ID in the child table. This simply instructs that this should run for each customer. Right. And now each customer will be reported and this investigation will be done for each. So the two queries are connected. This is correlated. So we're going to be showing you each customer and the date the last transaction was made. But notice I can run this query by dismissing this connection. Now this is a different kind of question. That connection has been destroyed, so this calculation will be done overall. And notice this value you get right here will be shown across the board. You see the same value, it will be pasted for every single customer. That same value, you see, is the same. Right. It is investigating the date the last order was placed, and it is showing that for each customer. Oh, sorry, the same for everyone. But if you want to investigate this last date, you want to do it per customer, this condition is necessary. This calculation, this investigation will be done for each customer. So each time the customer ID on the parent table matches the customer ID on the child table, investigate this. And that's why when you run this investigation, the values are different. See, you see different values showing up because this investigation is done separately for each customer ID on the parent matching customer ID on the child. So this is what we call a correlated subcode. These ones are not very popular, but it's just good to know them. And if you reverse the equation and investigate the first transaction of each customer, you just change this into a mean function. This one is a last, which is a max. So the first transaction of each customer, you just change that into a mean function. And this is it. So these correlated subqueries are not very popular, but I just want you to know about them. It's easy to identify them. They always have this reference. The column from the parent query is specified inside the subquery. So it makes the subquery not possible to run on its own. It is dependent on the parent. That's what we call correlated. There's a correlation between the parent and the child. Previously, we saw that we could highlight them. This one has no dependency on the parent. This is an independent subquery, or some people call it self-contained. It can run on its own. So whenever you don't see this reference of a column from the parent query inside the child query, this is, when you see this, this is an example of a correlated subquery. We're going to see more examples during the lab session. I really want us to get to this. Start procedures. They're similar to views, but then they use parameters. Right. If you can go ahead and open this this right here. So I'm not taking it to week 7, day 2, 7, day 2, and we're looking at stored procedures. There's a link right here taking you to W3 schools. Yes, so what is a stored procedure? A stored procedure is a prepared SQL code that you can save, just like what we did for views. You can prepare a code and save it. It will be saved in the views folder. Stored procedures are also similar. It's a prepared code, you can save it. But let me just show this. When you save a stored procedure, it goes into a different folder. So views, for example, let me open this database. Views go into this, stored procedures, they go into programmability, stored procedures. Very important. That's exactly where we saw functions. You see, we expand the functions, you go to system functions, you see the different groups of functions, categories of functions. So please take note that stored procedures, they are not in tables or views. They go into a special folder called programmability, and you can see them right there in stored procedures. So when you create a stored procedure, this is the folder that is going to contain them. This is a very important disclosure. So we've talked about tables, we've talked about views. So stored procedures, you'll find them in programmability. Every database has a folder called programmability. That's where functions and stored procedures are located. This is stored procedure, functions are right here. All right, so the goal of today is to talk about stored procedures. Like we said, it is a SQL code that you prepared, you can save it and it does a particular task. Right. So if you have a SQL query that you write over and over, you can save it as a stored procedure and then just call it to execute. Same thing we did for a view. You've taken your time, you've prepared a SQL query, you don't want to be doing it over and over. You can just save that query as a view. Right. So the same knowledge applies to stored procedures, but then stored procedures are powerful because you can the ability of taking parameters, and parameters will control the behavior of the stored procedure. So you can also pass parameters to a stored procedure so that the stored procedure can act based on the parameter. Right? Remember how we created a view, create view, the name of the view, and then we'll put the AS keyword. It's the same thing. We just have to replace the word view to word procedure or proc. Right. So that's what we're gonna do first. Right. So let's use AdventureWorks, this database, to complete this exercise. So create a stored procedure called this instead of a view. Right. Last time we used the same stuff to create a view. Right. So let's create a stored procedure instead of a view. So this is the code that has been given to us. See, this is the code. This is the only line we're going to add above it. You can do this same. This is the one line you add above to transform. This is the same thing we did for view. If I remove this and put view, I am not telling the system I want to create a view. Right. But since we're talking about, please, it's not stored procedure. We just type procedure. Some people just type the short form proc. Right. So it's not create stored procedure. No, it's create procedure or create proc. Right. And again, like what we discussed yesterday, this is your select statement. This is the only new thing we are adding to that. So first thing, let's review and understand this. We are showing each customer, we're extracting the year their order was placed, we're extracting the month, and we are showing the sum total due, total sales. So we are doing this for each customer over each year, month. So this has to go through the customer table, inner join, sales order header on this condition. Right, and since we have an aggregated column right here, it means that this, and this have to go into the group by. So this, and this have to go into the group by. So that's it, how we decode that process, and you can execute to show this result. Hopefully this will not take forever to execute. So I started off by explaining what this stored procedure will contain. It's going to be showing us each customer ID. We're interested in the year the order was placed, alias that as order year. We're interested in the month the order was placed as the order month. Now we sum the total due. One customer can place many orders. So across the year and month, let's sum to get a total sales. This is taking forever to execute. Are you having the same problem, or it's just, did you, I just, for now, just run the select. We're going to add this. So once you add this line on it, it creates the procedure and then saves it in the stored procedures folder of the database. All right, so for now, I just want you to, let's understand this part. What is this query doing? All right, if you have any question on this part, let's address it before we add this part. So by adding this line, you're actually transforming this into a stored procedure, and that will be saved in the database server, you see, for that particular database. So this is really frustrating. So I'm just going to wait for this to execute, or prefer I can shut it down and relaunch it again. Let's try that. Let me shut this down. So usually if you can just right click on the application, close the window. I'm going to prompt you, the query is currently executing. Do you want to cancel the query? Yes. I just want to shut it down, and I'm going to relaunch it again. Hopefully it can have a better performance. You want to save the changes. So that has shut down. Let's go ahead. I'm going to launch it again. While this is loading, you cannot do a select star on a stored procedure. You can do a select star from a view. This is important. It is a procedure, so you have to execute the procedure. You put the keyword exec or execute in full. So this is very important. This creates a stored procedure. To execute a stored procedure that you've created, you use exec or execute. So there's a difference between a stored procedure and a view. Views you can run a select star from a view. Views are virtual table. So select star targets a table. A stored procedure does not render a table. It's a procedure that runs, so you execute the procedure. So you type the keyword execute or exec in front of the procedure. So for those who have executed that procedure, you can go to the next and just, if you've succeeded to generate the stored procedure, you can now do an exec on the name of a stored procedure, and it will then run and show you the result. So you cannot do a select star from a stored procedure. You can do a select star from a physical table and a virtual table, that's views. So views, to see the content of a view, you do a select star from the view. For a stored procedure, it is a procedure, you have to execute it. Right, that's a very important difference I wanted to make. Let me try this again. I'll open that. So we're going to week 7. I think you have that open already. Let me just catch up on that. 7, the 2 stored procedures. So I was at this point explaining the behavior of this query. First thing, let's connect to this. So I was explaining what this query is doing. It is showing each customer ID, the year the order was placed by the customer, the month, the summation of the total due, and of course we have to group by all the non-aggregated columns. Right, now if you execute this together with the create instruction right there to transform this as a stored procedure, make sure you're on AdventureWorks 2022. Once I click on execute, the system is going to process that query and transform it into a stored procedure under this name. So if you are looking for this stored procedure we just created, you have to focus on this name. So let's trace that. You have to go to the Object Explorer window. I did a refresh. The database on which the stored procedure was executed against is the AdventureWorks 2022. This is still slow. I have to go to database folder and just deloading. Okay, this is really slow. I'm sorry about this. Okay, so I'm going to go to AdventureWorks 2022. It's right here. So what we just created is a stored procedure. You're going to find this in the programmability folder. Just waiting for this to load. Okay, so we're going to go to programmability and right here, stored procedures. If I expand, I'm going to see the list of stored procedures available, and we cannot actually see the one we just created. If you cannot see, just refresh the folder. So I think mine is right here. This is a user specified customer totals right here. And just like what we did yesterday, you can actually right click on a stored procedure. And if you see the scripting option, yesterday we saw script view. This is a stored procedure. So it's a script stored procedure as you can now put it on create, put it on a new query window. If you want to alter the stored procedure, you switch to this. See right here. So the same thing we did yesterday on views. Start by showing you how to create a stored procedure. If any changes need to be made on the stored procedure, you have to switch to alter, and then you do the adjustments. So that's the same query we evaluated. This query has been transformed into a stored procedure called this. Right, so that is the location of the stored procedure. It is in this programmability folder, stored procedure, and you just find it on the list. You can right click and script it out if you don't have access to the script. Right. So this similar thing we did yesterday. Right. So the difference, here comes the difference, one of the difference between a view and a stored procedure. How do you test the stored procedure? You can explore a view, you can do a select star from a view. If you do a select star from a stored procedure, right, that's not possible. Right. You have to understand there's a huge difference. Right. So if I go ahead and execute this, this is not allowed. You see, the system is trying to process this as a table. There's no table or view called this. This is actually a stored procedure. So you have to execute a stored procedure. You either put exec or execute. And sometimes if the stored procedure has no parameter, you can just highlight and click on execute. You see, it runs. This is the first time I'm showing you how you can just highlight an object. You cannot do this for a table. You cannot just highlight a table and click on execute. You cannot highlight a view and click on execute. This is available for stored procedures. You highlight and execute, or you can type exec, then you call the name of the stored procedure, execute it. Alternatively, you can type the full word execute, and you see these are the possibilities. One, highlight the stored procedure, execute. If there's a parameter, this option will fail because it will need you to specify the value of the parameter. So this is working because this stored procedure has no parameter. We're going to see the next one with the parameter. So one option, highlight, execute, put the exec keyword in front of the stored procedure, or put the full execute right there. See, this is very important. The stored procedure is executed. You cannot do a select star from a stored procedure. Right. Now, modifying the stored procedure, that's the process of altering it. So modify the stored procedure created in question 1 to include a parameter. This is where parameters come in. And this symbol right here is used to indicate a parameter. Right. I was normally supposed to talk about variables, but I'll discuss that during the lab session. So this is coming from a variable perspective. I will show you how we create variables. So this symbol right here indicates a parameter. Right. So the name of a parameter begins with this symbol. Same thing with the variable. The name of a variable begins with this. Right. So use the parameter in the where clause. And let me show you an example. So we go back to that query, we change to alter. If you keep it on create, just like what we saw in views, you cannot run this and run it again. This has already been created. If I try to highlight why I'm on create and try to run it out, it's going to give me an error. The object already exists. See, you can see it right here. You cannot run the create again. So to modify this, you have to change to, you have to switch to alter. Once you're on the alter, there's the same name. Now this is me adding a parameter to the stored procedure. So see, some people put this on the same line, some people put it on different line. This means I want to add a parameter into my stored procedure. and this is the data type. What values can the parameter accommodate? Integers. Right. So I'm transforming customer ID as a parameter. This is the symbol of a parameter. Every parameter must have a name with this symbol in front of it and a data type. And then once you do that, you use it in the where clause. This is a where clause. I'm now saying that the customer ID should be equal to whatever parameter that will be passed. You see, now this is what you see. When I call the stored procedure, I have to specify a particular customer ID. So it is equivalence of saying that run this query and use this. So a parameter just is a container that you can pass any value. Each time you call the stored procedure, you just pass in a value. It will take that value and replace the parameter and run it. Right. So we're just holding this, specifying this, and giving the user the power to control the behavior of the stored procedure by specifying different values to the parameter. So as I'm calling the stored procedure, I'm specifying different customer IDs. The behavior of the stored procedure is changing. So a parameter is just that container, right, which is available. You can pass any value, right? But the values must be integers, because when I define the parameter, I specified it will accommodate integers. So now I've changed this stuff. When you call the stored procedure, you must provide a value. This value will now filter the stored procedure since it's placed on the where clause. I will now say the customer ID should be equal to whatever customer ID that will be specified when you call the stored procedure. So these values you see right here will go to this. If I specify this, it will be fitted right here and executed. I'll only see orders tied to this customer. If I specify this, it will go right here and I'll only see the orders coming from this customer, you see. So it makes this process dynamic. So it's one procedure, but then it has the power to accommodate different values, and that's the power of a parameter. So this is how you do it. First of all, state the parameter. The name of a parameter must have this in front of it. This is what tells the system that's a parameter or a variable, and then it's a data type, and then use it now to control the behavior of your stored procedure. You must put in the where clause. So if I go ahead and execute this, I've transformed that stored procedure into a parameterized one. It runs on a parameter. See, it has modified the definition. And now see what happens. If you try to execute this like what you did before, it fails because it doesn't know the value having provided. This stored procedure runs on a parameter. Each time you execute a parameter, you must provide a value. The parameter cannot be left empty. You must provide a value. So if I highlight this, execute, I'm violating that. If I run this again, it's a violation. You see, it tells you that the procedure needs a parameter and the parameter was not provided. And the parameter is what? Customer ID. So whenever you provide a valid customer ID when executing the stored procedure, the system will use this value in this. It will dismiss this and put that value. So this is just like a container. When I run this, it puts that, you see, the customer ID has been fitted, you see, where customer ID equal to the value that was specified during the execution of the stored procedure. That's why sometimes you can call a business and they ask, what's your customer ID? You just provide it, they type in the system and they see all your transactions. In a bank, right, or whatever, it's a procedure that has been built and they have a protocol they follow. If you're in a university, you call maybe the registrar's office, ask your student ID. Once you provide the student ID, they call maybe a process like a stored procedure, indicate that ID right there, and they run it. The system will now go and fetch your records based on the ID that was provided. In SQL, this process is done through what we call the stored procedure. So it's one procedure you've built. You can pass in any value and it will filter and render just what was requested. Right. So you build it once and you use it forever. See? So this is really powerful. Just give me your customer ID. I'm going to call the stored procedure and reference your customer ID. It's not a comma, nothing equal. Just put just the way you see right here. Execute. See? And each time you call, the value, the behavior of the stored procedure is changing. You see, it is focusing on just that ID. Run that. See, this person has 3 orders. See that 3 orders tied to this particular customer. See? So remember, it is one procedure we've built, and we've used the power of parameters so that whoever is running this procedure, right, can dynamically put in their own IDs and run it. See? If I just go and put where customer ID, this is what we've been doing hard coding. We just go and put it right here. If I build this and save it as a view, I've just condemned this. You can only see these values, nothing more. You can only see this. See, what if I want to change and see something different? No, I've hard coded it. Anytime you run this procedure, it will only give you this. But you can make this dynamic. That's the power of a parameter. You see, you introduce a parameter into it and say, hey, whenever you run this procedure, choose the customer ID you want to view, and you just pass it. It will replace the parameter, right? So this value is what will be placed right here in the position of the parameter. And so when I run this, I get just the customer ID that I specified. You can clearly see that this customer has 2 transactions. So it's one stored procedure that has been built to address any customer ID you pass into it. Right. So you can use any column and decide, okay, this is what will drive this stored procedure. Right. See this example, modify the query above to now support 2 parameters. Right. So I'm now using 2 parameters. This is creating a new one. See, I'm back to create because this does not exist. Right. You give me the month and you give me the year, and I'll give you all the sales transaction we have for that particular month and that particular year you've provided. You see that? This is parameterized. It runs on a parameter. And so it is very important that when you specify a parameter, you use it in the where clause. The goal of the parameter is to filter or influence the behavior of your stored procedure. You see, so this is month. So I'm saying that the column that captures the month of the order day should be equal to whatever value will be passed in the parameter when the stored procedure is called. And you see, this is mandatory. The 2 parameters are mandatory. You have to provide a year, and you also must provide the month. See, and whenever you do this, let's go ahead and execute this. So this creates that parameter. This stored procedure has 2 parameters. It has been created. You can now refresh. Let's refresh either the database or just the stored procedures folder, and you're going to see that new one created right here. How do you test it? You must provide a month, and you also must provide a year. If I just run this ignoring the parameters, I get an error because this is a stored procedure which uses parameters. The system reminds you that the procedure you've written expects parameters month, which was not supplied. I go ahead and provide the month parameter, execute. It is not enough. It complains further. The procedure expects a year parameter, which was not supplied. So you must always make sure you meet the requirement to provide all the parameters needed for that stored procedure to do its job. If you notice, all the year is tied to 2013 and all the months are tied to September. See, that's it right there. So the parameters are filtering the stored procedures. You can keep changing them. Some other people do this. They kind of do this equal to this. This is another way to code the name of a stored procedure followed by the name of the parameter equal to the value you want to run at a particular time. Put a comma, the next parameter, and the value you want to run at that particular time. See? And please take note, if you do this and this, you must maintain the order in which the parameters are defined. So what I'm saying is this. You cannot begin with the year because the system recognizes that this value goes to what? The first parameter that was defined, month. And this second value goes to the second parameter that was defined here. So you see, I've reversed that. You see what this is normally what you're supposed to do, and you get this nice order. Then goes to the month. 2013 is the year. If I reverse that, let me run this. There is no month that is 2013, and there's no year. So take note. You can actually reverse this if you want to. You can make sure you specify this. This is carefully telling the system that the year, in this case, is 2013, and the month parameter is 10. Yeah, this is allowed if explicitly defined. Right? But if you don't want to go through indicating the parameter and the value, indicating the parameter and value, you must make sure you type the value in the order in which the parameters were created. I'm going to dismiss this so that it doesn't confuse you. Right? So this is the power of stored procedures. You build one stored procedure and the users can come in and decide, okay, I want to view this particular data. They enter the value for the parameter, run it, it changes. Right. There was this query we saw yesterday that was taking forever to execute. I don't know about this query. Right. It was taking forever to execute. So I've decided to, you know what, let's transform that query to a stored procedure called this. So I'm giving you the name of the stored procedure. Now let's use sales order ID as a parameter for this stored procedure. I don't want us to sleep right here. I'm not going to execute this. It's going to take forever. Let's first of all package that as a stored procedure under this name. So what do we need to do? Just, I'm going to preserve this. I'm going to copy this below. All right, so the title right here is going to be creating. This is a practice exercise. I didn't provide a solution so that we can do it together. So creating the stored procedure. All right, so go copy that, go below and type this, creating the stored procedure. The query has been provided. Just transform it into a stored procedure. All right, now I'm going to paste this. That's the query. And then how do you transform that query into a stored procedure? Let's first of all go copy the name. This is the name of the stored procedure. All right, so this is the code right here. The only thing I need to add is this line above. Create. What are you creating? You're creating a procedure. Some people will say proc, which is allowed. You enter the name of the procedure. Now, if you go back, you understand that this stored procedure we want to create has to use this as a parameter. So use sales order ID as a parameter. So whenever you call that stored procedure, you need to provide a valid sales order ID so that it filters and give you only the sales transaction for that particular order ID. So this is how you do this. It's a parameter, you must put this symbol before you put the name. So this symbol indicates to SQL Server that this right here is a parameter. Every parameter must have a name. Sales order ID is an integer. The name is right there, and the data type is right there. And then what are we missing? The AS keyword, just like what we saw in our views. This is not enough. You must now take this into the where clause. The power of a parameter is the ability to filter the procedure. So this is us incorporating this. This is going to be a valid column in the query. So we are having sales order ID. This should be equal to the parameter so that when you call the stored procedure and provide the sales order ID, it will now dismiss the parameter and put that value you specified. So this behavior is very important. Please remember, it is not enough to tell the system your stored procedure should have a parameter. You must use it in the where clause to filter the result from the stored procedure. This is what will give you that ability to change the outcome based on the sales order ID you specify. So you see where the sales order ID from this table is equal to what the user will specify when calling the stored procedure. So that's the parameter right there. If you go ahead and bundle this, oops, where does it begin? It begins right here. This is just to that go stuff, make sure that the parameter, the stored procedure is the only statement in the badge. It's not a big deal. Just package this, highlight this, and execute. This creates a new stored procedure that is parameter driven. See, it creates this one run fast. It's creating the procedure. Now you can now test the procedure. Let me first of all show you the procedure was created in what Adventure Works. It's the same database. I'm just going to refresh the stored procedure folder. The name of the procedure was, let me look up the name right here. Transaction details by order ID. Transaction details by order ID. This is it. I can right click and ask the system, hey, can you show me the script that was used to build the stored procedure? The system will work out the script and render it. Right? So like we said, there's no excuse for you not knowing the script for a stored procedure, a view, a table. You can always investigate that. This is it right here. Nicely done. See? So if you want to test this stored procedure, you have to make sure you provide some sales order ID. So testing the stored procedure, that's the next thing we're going to do. So this part, we've created it. The next part, let's do the testing. Right, so testing the stored procedure, you have to test this against valid sales order ID. So how do you call a stored procedure? Exec or execute will do. Specify the name of the stored procedure. Let me just go ahead and copy it right here. Right. And sometimes it's always good to reference the schema. This goes into DBO. Right. If I run this, it's going to fail. Why? Because the stored procedure runs on a parameter. So if I execute this, you see it gives you an error. And it reminds you that what you executed is a stored procedure. It expects a parameter sales order ID. This thing is very smart. So you need to provide a sales order ID right here. Can somebody give me any one valid sales order ID? Just I will need to run the entire query right here. So you just take this, or instead of running the entire stuff, sales order ID is coming from this table. Right, since I'm having that issue of slow performing query, my server is, see, just to load a new query, it's taking forever. I just want to do a basic investigation, or somebody can just give me any sales order ID so I can test. Okay, Alex, this is 43659. Yeah, this thing is still messing up. So once you've created a stored procedure, just pass any call, do exec, put the name of the stored procedure, and pass and specify any sales order ID. When you execute that combination, you will get something interesting. So I'm going to go with, so just a moment, let me check the, yes, so Alex, you provided this. I'm going to copy that and just put it right here. So if I call the stored procedure, so I'm actually on practice one right here. How to specify this. This is very important. If you just do this part alone, this only works when you have a stored procedure without a parameter. Once your stored procedure has a parameter, that parameter must have a value. You see that this, how this where clause execute, it takes this value specified and puts it right here and then runs it and only gives you the transactions that are tied to that particular sales order ID. So it makes it easy. Instead of seeing all the transactions, we are only looking at those from that particular sales order ID. Like, the system is still slow in processing that. I think yours should run faster since we are targeting only a specific sales order ID. Remember, one sales order ID can be tied to many transactions. So if you run this, you might see multiple rows being written. It just depends on how many transactions the database engine can find that is tied to this particular sales order ID. Yeah, mine is still running. So when you're dealing with the table that has too many rows, you see I'm trying to restrict. I just want to get the top 10. Right. This is still running. So I'll just wait for this to run. So please go ahead and do a couple of tests. You can run this again, test another value. But I think by now you understand that for you to execute this third procedure, you must provide a sales order ID. For each run, you must provide a sales order ID. And that's the power of this. I'm going to do a couple of tests across different sales order ID. All right, this is going to take a while. This is still running on. All right, this is still running. So I'm still waiting for the result of this one. Has anyone had a result on this execution? So mine has been running for like 2 minutes, almost 3 minutes.
Mine took only a second, so I don't know why. I'm
Yeah,
sure
so
something wrong with your
yeah,
SQL or something.
my stuff is really, yeah, I will need to troubleshoot and understand what's going on. This is really slowing down the lecture. You see the power of the parameters incorporated in the stored procedure. It's easy. This symbol, please don't forget this. I mean, sometimes you might forget it, but you're gonna get an error. All right, so this is a stored procedure we want to create. And then this is indicating that it's going to run on the parameter, which is going to be based on city. Right, so you now have to add it on the where clause. So the city column, the value in the city column should be equal to the value you're trying to test. See that? And always a stored procedure is defined together with the data type. This is going to be a string, nvarchar 30. Right, any city you want to enter into this must not be more than 30 characters long. That's the meaning of this. It's a constraint on the number of characters for the city value. Right. And always remember exec or execute, specify the name of the stored procedure. You can just type this, the value, or you can put the parameter equal to the value. Right. So if you do exec, select all customers and you just put London. This is string, right? As you understand why we have that string environment. Right. So that's one parameter. You can also do multiple. So we have city is going to be a string, that's the data type. We put a comma and add another parameter, this data type, you see. The power of this is the ability to add it in the where clause. So the city column should be equal to the value that you will pass in the parameter. The parameter can hold any value. You give that power to the report user or whoever is running the query to specify their own values. So they are going to put a value for city, say for example, city equal London, and also a value for postcode, the postal code equal to this. And the system is going to run this and give you the transactions from this particular city and this particular zip code, postal code. Oh, this is still running 5 minutes. Yeah, this is definitely serious error, serious issue right here. And usually, since this table is involved in a process that is taking forever to run, if I just try to, although I've put top 10 right here, if I just try to run this, it will also affect that. See, because this table right here is involved in the running of this third procedure. Right, and since this is still running, it is using up that table. There's traffic sent to that table requesting those rows, and it's also affecting this from a different editor. Right. Sometimes you have this issue when you ignore the updates that is prompted on your laptop. Run some certain updates, security updates, you ignore those, it slows down your machine. Right. So it's a lot of factors that can contribute to this. Sometimes they start the storage space on your laptop, maybe it's getting full. Right. These processes we run, they consume bytes on your space on your laptop. Right. And just imagine you do this for this SQL runs for like 8 weeks or 9 weeks. It's a lot of, right? Yeah, this thing is still running. Imagine, right? Okay, so I think we're gonna end here for today. I want you guys to go ahead and read the 8 week is gonna be an interesting one. I have like 3 key topics that we have to touch base on, right? And once we cover those 3 key topics, a good number of the database, the interview questions on this, you will be able to understand them. For example, derived tables, common table expressions, a good number of the questions in this interview segment will involve those. For example, let me show you this Uber one. So in this Uber one, you want to write a query that to obtain the third transaction of every user. When you hear about third transaction, okay, first of all, you have to sort the transactions. You have to use something like a window function. You want to see all the transactions, but then you arrange them in the order in which they occurred for each user. So you have to do something like a partition by user, and then you arrange the transactions in the order in which they occurred. Good news is that we have a transaction date. Right? So you can use the transaction date to do the sorting. For example, if I just go in there and do an order by, first order by the user ID. Order by user ID. Second, this is one of the questions we saw today. Can you use multiple columns in the order by? Can you sort by multiple columns? And we said, yes, I can then add this. This is acting like a tiebreaker. So once you sort by user ID, continue the sorting by transaction date. So if I run this code, this is always an issue. Let me refresh this. That's why I prefer to have the copy of the database so that you can run this on SQL Server. Right. Okay, I'm having, this is more like an internet issue. Okay, this one finally executed. It took 9 minutes. That's a lot. So if you look at this request, it's tied to a particular sales order ID. And if you go to the sales order ID segment, you see right here. All right. And remember in this question, we did a certain, is it the question we did? So, right here, there's a window function right here. And we did partition by sales order ID. See? All right. And so we are targeting the sales order ID for that particular one. There's only that is shown, you see. So when we call this stored procedure and we'll focus on this sales order ID, all the 12 transactions we see right here, they are tied to that same sales order ID. See? Some other person will call it and use a different, let me change this. This is what I wanted to change this to this sales order ID. Maybe if I run this, it's going to take another 10 minutes. All right. But I'm just going to put this, and then you can use this to test your stored procedure across different values. See, I hope these are all different. Yes, no, this is the same. Let's go for a different one. So this is a parameterized stored procedure. It runs on a parameter. Any attempt to run the stored procedure without specifying that value, you get an error, right? And this is really powerful, right? Yeah, I want us to end here for today. There's one more example, one more practice. I want you guys to practice this, right? So in this one, you're going to use this query. It's a query we saw yesterday. We did this yesterday, where we're classifying customers based on what they are. We first of all computed their duration, number of years in the company, and then we did the case statement to do the grouping. So this is the instruction. You're going to practice this one. Transform this query below into a stored procedure. This is the name of the stored procedure. And while doing this, you have to use the years employed as a parameter for the stored procedure. Right. And please take note that you cannot use an alias in the where clause. So once you specify the query, this part right here is not needed. Let's just kick out this part. So once you've specified the query, the stored procedure, on the where clause, you cannot take this alias and put on the where clause. You have to take this entire expression. This is very important, see? So transforming this into a parameter, a stored procedure, then a parameter. This will be what you will use in the where clause. Right. In fact, let me just go ahead and indicate this. So this will be the transformation. Let me first of all copy this, right, and do the transformation below. Right, and then there's the second part, it will tell you now to modify the stored procedure. That's when you use the alter, switch create to alter, and then add these following columns. So let's do the first part. So again, creating the stored procedure. Anyway, I'm going to leave this as an assignment. We're going to see it during the lab. We're out of time. So you do this practice question 2, and I'm going to check it out during the lab session on Wednesday. Right. So this should be a parameter. So when you filter on the years employed, for example, if I call the stored procedure and I put 5, I should only see those who've been in the company for a total of 5 years. If I switch 5 to 3, I should see only those who've been in the company for 3 years. All right, that's the power of a parameter within a stored procedure. Right. Okay, let's end here for today. Remember, you have this to do. Right, and I will look for more questions on stored procedures. The concepts we've covered this week. So stored procedures, views, subqueries. Yes, I'll put up some projects on this so we can explore them. Any question before we go? Okay, so in order to avoid you not missing lectures, please make sure you reach out to Velin if you've not complied with the fees payment and stuff like that. I don't want anyone to miss classes because of such a reason. All right, so make sure you reach out to Velin. Okay, see you during the lab session. Bye, everyone.
Bye. Thanks for today.
Okay, bye.